Hello everyone, welcome to ZaranTech. In today's rapidly evolving digital landscape, businesses require robust infrastructure to support their operations. Today, we are diving into the fundamentals of SAP BASIS HANA. SAP BASIS with HANA is at the forefront of this technological revolution. SAP BASIS HANA is a database management system that integrates data processing, application deployment, and management of SAP systems. With its lightning-fast processing speed, organizations can analyze vast amounts of data in real time, leading to a 50% reduction in reporting times and a 30% decrease in data storage costs. It enables businesses to make data-driven decisions swiftly, gain a competitive edge, and adapt to ever-evolving market demands. Throughout this course, we will cover everything from the basics of SAP BASIS HANA to advanced implementation strategies. But before we begin, please subscribe to our YouTube channel and hit the bell icon to receive regular updates from us. Now, let us look at the agenda. Agenda 1. SAP BASIS Roles and Responsibilities. 2. SAP Architecture. 3. SAP BASIS Overview. 4. Concept of SAP Instance. 5. System Monitoring and Troubleshooting. Let's dive in.
So first topic is SAP Basis Roles and Responsibilities. So before I go into SAP Basis Roles and Responsibilities, let me go a little bit about the SAP itself. So SAP basically a collection of software. SAP basically a company. The company provides collection of softwares. Those softwares are used to manage enterprise resources. So a company has different kind of resources, whether it's a financial resource, it's a material, or it's a human resource. So there are different kind of resources a company needs to manage and plan and execute. Okay, so those resources cannot be it can be managed for a small company, but it cannot be managed for a large company because it becomes so complex and huge. So that's why you need a system to keep track of it, and to manage it you need a system. So SAP provides that system. It's called SAP ECC, or now they have released S/4HANA. So the name of the software is not SAP. Name of the software is ECC or S/4HANA. The company provides this software. The company name is SAP. So back in 1972, few people were working on a tool or piece of software which is capable of managing finance for a company, and they were doing this for IBM. They were IBM employees. Okay, so somehow the project got closed, and IBM shut down the project. So then those gentlemen came out of the IBM and started this company SAP, and then gradually different version upgradation comes, and now you see where it is today. Okay, so in a single line we can say SAP provides the software to manage the company activities. Okay, now SAP is a huge software. Okay, it's a huge and complex software. So it is not possible for a single human or couple of people to manage SAP. Okay, there are different kind of tasks and different kind of activities which is managed by people having different kind of capabilities. So there would be finance related activities, there would be sales related, distributed related activities, there would be development of new features activities, there would be managing the system activities. So these activities are majorly divided into several parts, okay, and those parts called module. So in SAP, they have near about 30 plus modules, and each of those modules will handle a specific set of tasks uh, for the SAP software. Okay, so as I told you that a few example of these parts or modules is SAP Basis, SAP ABAP, SAP SD, FI, FICO, um, SCM. So these people handles a bunch of activities, interrelated activities, which is significant to the system. Okay. Now, one of those modules is SAP Basis. So what we do, we basically install new systems, new SAP systems. We upgrade, we update the existing system, and we do administrative activities like uh, opening, closing connections, and uh, giving user access. Also, we do migration to different platforms, whether it's a different hardware or different uh, database technology or operating system. And also we take care of the complaint from the user, that if there is any specific part of the system which is, or a specific functionality of the system which is uh, not accessible, or they are getting any trouble accessing it, or there is any performance issue while accessing anything. Okay, so we also do this kind of stuff. Any uh, any question regarding this? Any doubt regarding what I just explained? Like what are the basic roles of a SAP basis consultant? Good question. Okay. All right. Then we will talk about the SAP architecture. Uh, Let me open up a slideshow. Okay, now we will talk a little bit about the architecture of SAP. Okay, so previously the first version release is SAP R1. Okay, so R1 means R1 means if you think about the SAP technology, or how we access SAP, or how SAP is SAP architecture is designed, you will see that it is divided in three layers. Okay, so one is the presentation layer. So if I open up SAP GUI, and I will access the system. Then probably if I using SAP GUI or SAP Web anything, then there is no part of the system residing in my system, right? I'm just accessing it from my desktop. So that is the presentation layer. So only the presentation is happening on my system, neither any um, computation nor any data storage is happening on my system. So it's only getting presented on my system. So that is the presentation layer. And then there is the application layer. So the application which will be accessing, or the programs which will do the computation for us, it will be stored in a server, right? So the server is the application layer, and then the server itself or the application layer itself um, does not store the data. So data is stored in another server, you can say, uh, in the database. So that is the database layer. Okay. So now, just give me a moment. Okay. Now, if you see this picture, this is the application layer where we are accessing using either SAP GUI or the browser, and over the internet or through the internet, or if it is a private network, then over the network, you can say, we are reaching the application server. So this server containing all the applications which we will call through the SAP GUI or browser, and then the application programs reaching to the database, and it is getting the data and feeding back to our browser or SAP GUI. Now it is possible that application, all the application programs and everything, and the database resides on the same same server. So we took one server and we installed the application and the database in the same server. It is possible. It is called two-tier architecture. And when we have one server for the application, and that server is through network, it is connected to another server. In that server, we install the database, and all the data resides in that server. Then it is called three-tier architecture. So as I was started this topic using the term called R1. So previously, at the very beginning of the SAP evolution, actually uh, one server contains all three things. I mean, it was not available through the network, so there was no network in play. So if you want to use SAP, you need to log in into the server in which SAP is installed. So you cannot have a GUI installed in your machine and you connect to a remote system where SAP is installed. So that was not the case. In very beginning, it was you install SAP in a system and you need to log in into the same system to access the SAP. So all three, presentation, application, and the database, was present in the same server. Okay, so that's why it was called R1. Later, after few years, they released R2, and during that time, only available option was you install application and database in a server, and then you access from using the network from any other system. So then it becomes R2, and then during 1998 or 99 something, somewhere around that time, they released R3. So once R3 got available, then we had our option of installing database in a separate server. So the major benefit of this R3 architecture is you can have a dedicated database server, so it gives you better performance for the query you are firing. Okay, so if you are running application and database server together, then your resources, hardware resources, whether it is CPU or it's a um, RAM or any other hardware resources, is basically getting divided between application and the database. So if you are running a heavy query, then it is little bit you know the performance would be little degraded compared to uh, if you have a separate database server. So if your system is generating heavy load, then it will be little bit problematic. But the benefit is the response times is faster, because so if you have a system which is in which you are not firing any large query which is pulling lots of data from the database, it's just a small transaction. uh, by small I mean the volume of each and every transaction is small, then this is more beneficial. Okay, because your data does not need to travel through network. In this architecture, it is the data is basically traveling from the network. Now there are different ways to overcome this, like establishing a very high speed connection between application server and database server. That is a different topic, but in general, if everything stays same, then if you have frequent request or frequent uh, 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 connection, especially in transactional system. For example, if you go to the big bazaar, right? In the big bazaar, you have collected some things, and now you are at the billing counter. So every moment, the person which is on the billing counter enters the system, and the data or the price of the product coming from the database, like, right? But it is very small data, like few kbs or 1 kb 2 kb data, but it is coming from the database, right? Because all the product prices are stored in the database, but it is from the database. And then again, when the billing is completed, the entire billing amount getting stored in the database. So very frequent uh, transaction is happening to the database, but the volume is very small. Each and every transaction is very small. So in that case, this is more preferable. But if you have a system where you are running big queries, so you need a report of the sales for the last few months or something. Then a large sales data is coming to this. Okay. So in that case, it becomes little cloggy for this kind of system. Then you probably need a different architecture like R3 or something. Okay. So that is the um, architecture of the SAP. Now it's basically the bird eye view of the SAP, not the deep architecture or detailed architecture. So how we will go to the detailed architecture now. What if you have a SAP system? What are the things it is comprised of, and what are the parts it's needed to run? We will go into that. So before I move into that topic, do you have any question on this R3 architecture or client server architecture? Okay, so in broad spectrum, SAP software is basically comprised of instances. Okay, so instance in general, not about the SAP instance. In general, instance instance means a copy of something, right? A functional copy of something. So in SAP also, we have instances. So instance is nothing but the collection of few softwares or few executable files residing on the operating system level, and it runs on the operating system. It consumes some memory, it consumes some CPU, and then it responds to user request, or it performs some task. Okay, so let me go to the system and show you what I'm talking about. So we will be logging into the OS level. Huh? So for that we need to call a tool called uh, RDP. Okay, so we access it either from the OS level called remote desktop connection, or you go to the run and type mstsc. Okay, so by default, uh, the SAP installation folder is USR SAP. Okay, so if I go to this folder, I'll see that there are different folders in it. Okay, so what I'm telling you is each and every SAP system has a code name. Okay, and that code name is comprised of 3 letters. You can see here I have A4H and MJ1. Okay, and also we have H4A. So these are the SAP systems. These are the SAP systems. Each and every SAP system has a ID or code name, you can say. This is called system ID or SID. So here we have a SID, A4H and MJ1. These are the separate SAP systems. Okay, so whatever your server is, if you go to USR SAP, you will see that these 3-letter folders, and you see always it starts with a letter. It cannot start with a number, and it has exactly 3 letters. Not one more, not one less. Exactly 3 letters. So these are the systems. Okay. So now if I go into A4H folder, I'll go cd A4H, and now if I list it, I'll see that different folders. Okay, so I'll explain the significance of those folders. Okay, so first we have ACS02. So this is a instance. So as I was telling you, that instance is nothing but a collection of software which is running in the system by consuming some memory and some hardware resources, and it's doing some work. Okay, so for SAP systems there could be multiple uh, instance in a server. Okay, now these instances has its own folder in the dedicated folder in under the SID directory. So this USR SAP is a SAP installation folder, and under that you will have one folder for each system. So under each system you will have folders for instances. Okay, now this is a client software, HANA DB client. This is not an instance folder, and also this is not an instance folder. This is sys folder. It contains kernel. Now what is kernel? Kernel is basically collection of the executable files, and one copy of the kernel is also present in all those instances folder. So you will see that if a system has two uh, instance, you will see two instance folder under the SID directory or system ID directory. It has 5 instance. You will see 5 folder under the system directory, and you have to keep in mind that system can be of two types. One is central instance, another is dialog instance. So what is central instance? Central instance works as a mastermind of the system, or it controls the entire system. It is the brain of the system. So that is the central instance. So in a system, if we talk about, for example, A4H system, in each system there would be only one central instance. So if you go into the folder, any folder for the matter of fact, you will see only one SCS. So central instance is one. There should not, or there could not be more than one instance of the central instance. Okay, but the dialog instance can be multiple. So here we could have installed, or even any point of time we can install additional dialog instance like D01, D02, D03, unlimited number of dialog instance. Okay, it's not unlimited, actually these are called instance numbers. Okay, the 01, 02 you see, these are called instance number. So instance number can be from 00 to 99. During the installation, the system installer asks to you that what okay, I want to install this, I'm going to install this central instance. What should be the instance number? Then you provide 02. And then it will ask, I'm going to install this dialog instance. Um, what should be the instance number? You provide 01 or any number between 00 to 99. So there you go about the uh, restriction of the number of instance in a system. So in a system you can have maximum 100 number of instances, though it is not required, or this is not practical, but in theory you can have 100 number of instances from 00 to 99. So as I told you that there could be a multiple dialog instance in a system and one and only central instance per system. So the installation directory of SAP is USR SAP, and under USR SAP you will find one SID directory for each system installed in a system. So by that I want to mean is you can install multiple system in a single server. Okay, it is absolutely possible. So guys, you will notice that during this training I will emphasize some information over and over again. I will repeatedly tell few sentences. I will repeatedly mention couple of sentences. The reason is I am doing this purposefully because these are the fundamentals of the SAP basis, the fundamental knowledge of the SAP basis. Throughout your career, you will use that knowledge, and every day you will encounter with this knowledge. So that's why I am repeating those uh, sentences or those lines purposefully. For example, I have several times told you that USR recipe is the installation directory. So this is universal for all the systems. If you are if you are installing a system in a Windows, then also you will find this path. You will follow this path. Only the difference for Windows system is it will be located in a directory. In a drive. So if you are installing the SAP system in a drive, then the path would be E drive, for something like that. E drive and then USR SAP. Okay, the path would be like that. If you are installing the system in D drive, the path would be D drive and then USR SAP. So wherever you go, this path remains same. Okay, for the Linux, obviously the path is USR SAP directly. Yes, sir. Okay. So this is the installation directory of the SAP. Under this directory, there would be a 3-letter directory for each system, and this is called system ID or SID. And system ID comprise of 3 letter. It cannot start with a number. It can start with a letter. Then it can have either letters or numbers. It doesn't matter. So a valid SID is, for example, I can give A99, that is valid. Okay. And I can give AST, that is valid. I can give A09, that is valid. I can give D AA, that is valid. Okay. So anything 3-letter which is starts with a character. Character I means the alphabets actually. If you cannot include any special character in the uh, system ID. So these are valids. But if I start with 5AA, is it valid? It is not valid because it starts with 5. So here we have the system directory or SID. Under the directory, there is 3 important folder. One is sys folder. In this folder, the kernel is there. So what is kernel? Kernel is the very heart of the SAP system. All the executable files to to run the instance, to connect with the database, to use the RAM, to use the CPU, anything, to use the network, anything related to the OS networking operating system, that is belongs to the kernel. The executable file which will actually run on the SAP on the OS level and do the job, that is part of the kernel. So you see 3 main folders here. One is a sys folder, another is a central instance, another is one dialog instance. Now dialog instance can be multiple, more than one, but at least one should be there in the system. Otherwise, system will not be functional. And there should be one and exactly one central instance. This central instance, you cannot have multiple central instances in the system. And you can have multiple, but at least one is necessary for the dialog instance. And one sys folder, in the sys folder, there would be some security files and some kernel files. Now, one copy of the kernel is also present in all these 2 folders. I'll show you in a bit. And this is for HANA-DB. We are using HANA-DB as this is a S4 HANA system. Then we have this HANA-DB client. Now, this is not necessary that you install HANA-DB client in this location. You can use other location. So that's why I'm not saying this is a mandatory or this is important or this is a significant folder. Major significance is of these 3 folders: one dialog instance, one central instance, and one sys folder. So if I go into the sys folder, let's go to the sys folder and I'll show you what's in it. So here you can see few things. In this 2 folder is very important. One is exe, another is profile. So I will not go about the profile right now. It contains the parameter, and the parameter defines the behavior of the system. So we'll go very deep about the profile parameters and how we can manage it through the OS level, through the SAP, and how it controls the behavior of the SAP system. We'll go about it later, but now for the time being, understand that in the sys folder there is 2 important folder. One is exe and one is profile. Okay, so let's go to the exe folder, and I'm in the exe folder. Here you can see that there are different folders. So your exe means the kernel, right? Your kernel will be resides in these folders, okay, especially these UC, NUC, these folders. So if your operating system is Unicode, okay, and you are using SAP Unicode system, Unicode means it's the character set, okay. So the type of the character set you are using in the system. So this is not very I mean, it's not a thing you have to understand very deeply. You have to just have an idea about the Unicode and non-Unicode. So non-Unicode and Unicode is basically representation of character. For example, I have written this character, right, SAP, or this thing. This is stored in the system, or system is out getting me the output, right? So somewhere it is stored in the system and it is represented in the system, okay. So if these characters are stored as a Unicode character, then the system or the platform is called Unicode platform or Unicode system, okay. And if inside the system it is not stored as a Unicode, then it is called non-Unicode system. So if you want to learn more about this, you can always do a Google search, but for the time being I'll not go into much more deep on Unicode, non-Unicode. Just understand that it is a representation of character, how the character is represented in the system, how it is stored in the system, how it is translated in the system. That is called Unicode or non-Unicode, okay. So if your system based on the Unicode system, or Unicode, if your SAP installation is Unicode, then the kernel would be under this directory and this would be blank, okay. This is for debug purpose and other purposes. So here only important thing is the new Unicode and non-Unicode. So this system is Unicode version. Nowadays all the systems based on Unicode, non-Unicode system has retired. But if you are going to do administration, you might encounter one or two system which is still on the non-Unicode version. So ideally this should be empty, okay. So then there is a folder which is for the operating system version. See, now this folder is empty, right? Nothing is there. That's what I was talking about. So now let me go to the UC folder. So here you can see all the files. This is the kernel, okay. These things, these folders, files is the kernel. So as I was telling you that kernel is consist of lots of executable files and other files which is necessary for the system. So these are the files for the kernel, okay. All right. Okay. So one copy of the kernel is also stored in the run directory. So here you can see in the CD folder there is a folder called run, and one copy is also stored in the run directory. Okay, now let me go back to the instance folder once again. So let me go to the D01 first. So here also you can see one exe folder, right? So this is basically copy of that exe folder, CCexe folder. So when system starts, it's basically sync this CCexe to the instance exe folders. Okay. So if you go to this exe folder, Here you can see the same copy. Okay, so at the beginning I was telling you that instance is basically a self-sufficient building block of the SAP system. So the reason I tell self-sufficient is it has its own copy of the kernel, so it can run in the system. Okay, and one system is started using these executables, it starts and it start processing request and it start doing other works. So up until this time I was talking about the instances in general, but as I told you, there is two type of instance. One is central, another is dialog instance. Now let me discuss a little bit about why we have two different type of instance and what are the significance of those two instances. Okay, so let me first go to the talk about the central instance. Before that, I'll change the user to A4 HDM. Okay. Don't worry about these comments and all. I'll brief you later. No problem. Okay, so as I was telling you that we have two type of instance, right? One is central instance and another is dialog instance. And for each instance, there is a number assigned. So here you can see for dialog instance, we have assigned 01. This called instance number. And during the installation, we can provide any number between 00 to 99. This is not anything comes from SAP. This is decided by us which number we will assign to which instance, but it has to be it has to reside between 00 and 99, and second is it should not be used by any other instance in this server. Okay, so now we are looking at the details of the 01 instance, which is the dialog instance. So here we can see there are several process running. Okay, first one is dis plus work process, second one is IGS, third one is gateway, and fourth is ICMan. So if you look closely here, you will see that these executable files are there in this kernel. Okay, for example, this is the executable file for the dis plus work. So this is the executable file and it is running in the dialog instance, or dialog instance is running, and inside those dialog instance, these four processes running. So it's not inside per se, it is running at the OS level, and the process is belongs to the dialog instance. It's not inside, there is no container or anything like that. Simply when system starts, it's basically running this this executable from this instance, and these processes belongs to the dialog instance. Okay, also you can find this ICMan. If you just here, you can see ICMan. This is GWRD or gateway process. Also you can find IGS also. It should be here, it should be somewhere here. This one, no, what is the name? IGSWD_MT here. So these are the four executable files which is running at the OS level, and it is doing some work. and these 4 processes belongs to the dialog instance. So dialog instance nothing but some executable running at the base level, consume some memory and CPU, doing some work, and all together uh, it it creates this dialog instance. So what is dialog instance actually do? So dialog instance basically do the work for the users. So whenever you log in into the system, you basically connect it to a dialog instance. It it takes the input or command from you, then it do the computation. If it is required any data from the database, reach to the database, and it get the data from the database. It does the further computation, and it's return back the user. So all the things which we do in the system, for example, here I'm executing a transaction code. Let's say I'm executing this transaction code SU01. So as soon as I entered the SU01, it reaches the dialog instance, and it says that okay, the user wants the SU01 screen. So it reaches again to the database, it fetches the data, and it calculates and it computes, and it after to the computation it gives me back the screen. So the entire thing is done by the uh, dialog instance. So now the question comes, if the entire thing is done by the dialog instance, what is the significance of the central instance? Because I don't see here central instance coming into the picture. All the works is done by the dialog instance. All user inputs, taking instruction, reaching database, calculation, everything is done by the dialog instance. So what is the significance of the central instance? So for that, let me first show you what are the components of the central instance. Okay. So now you can see the components of the central instance: message server, enqueue server, web dispatcher, and gateway. So again, this message server, enqueue server is available in the exe folder. Okay, so let me just give you pull out the kernel files. So usr sp a4h, then scs exe. So now if I do a listing, here you can see that enqueue server and message server. Where is message server? Here is the message server. So these are the two important service of the central instance. So what it does, first is the message server. So message server is the brain of the SAP system. Okay, dialog instance and dialog instance process, these processes are the worker of the SAP system. But the brain, it does not do much work. Only it keeps a track of all the work being done by the dialog instance, and it collaborates between the application server or the dialog instances. Okay, so this is the master of the SAP system. This is the first thing started when we start a SAP. This is the first thing started, and once it is started, it starts to um, see what are the systems are available under this particular system, and it starts to uh, keep a note of the uh, status of those application servers. Okay, so basically the message server is a service or a server which keep tracks of the other components of the SAP system. It sits at the top of the system, and it overviews, or it controls, or it keeps a track of the all other systems and instances. Okay, and another important service is NQ server. This server is basically keep track of the logs. So logs is basically when you are accessing a data or you are editing a data in a SAP system. At that time, if any other person try to access the same data or try to change the same data, then there would be inconsistency, right? So SAP system keeps a track of those data which is getting changed or people are editing. So it keeps a list or it keeps a track of those data, and if anyone else try to work on the same data, try to edit it, it gives a little warning that no, this is not possible. Someone else is working on this. So these list is kept by this NQ server. So NQ server is basically a log tracking service which keeps a track of the log. Okay. All right. So in order to explain a little bit more about the message server, I'll let me draw a diagram. Okay. Let me draw a diagram. All right. I can show you in this. Okay. Here if we understand this slide, it will be very easy for you to understand the requirement of the message server. Okay, so we have seen the SAP system works in a 3-layer, right? Presentation layer, then application layer, then the database layer. Okay, now that is one thing. The another thing for the SAP architecture is how your application layer and the database layer, how it is constructed. Okay, so your system can be of two types. One is the single instance system, another is distributed instance. Okay, so what are the difference between two? The difference is when you have SAP instance or SAP application and database in the same server. Okay, so then it calls the single instance system. Okay, if you have a server and you have installed your database and application inside the same server, it is the distributed. It's a single instance system. But if you have your database in another server, your SAP in another server, so this is called distributed instance. And the system is distributed system. You can call it distributed system. Okay. So also you can have multiple servers for your SAP system. For example, if you consider about this picture, you have one server for the database and one application server. Inside the application server, you have one central instance, one dialog instance, typical scenario, one database instance, one application instance, and in the application server, you have central instance and database system. Then you have another server. In the server, you have two additional dialog instances, and then there another server, and in that server, you have two another dialog instance. So if you consider about the entire picture or entire system, for example, this is our A4H system. So in the A4H system, we have one one database server, another primary. This is called primary application server. Okay, this is primary application server because it has the central instance. So this is primary application server, and then there is a additional application server, and in that additional application server we have multiple dialog instances. We cannot have central instance because I told you that central instance should be one central instance per system. So whichever server having this central instance called primary application server, and another server, there could be multiple application server, more than 100, more than 200. There is no limit of application server, but those are called additional application server. And in the additional application server, there is dialog instances. So in this scenario, users would be either connected to these dialog instances separately, and from this dialog instance they will connect it to the database, and then they will respond back to the user. So that is one scenario. Another scenario is you don't configure the dialog instance directly in the user's UI. So here in the GUI, we have entered the details of the dialog instance, right? This is the application server IP address. This is the instance number. Instead of that, what do? You give the details of the central instance. So central instance, instance number, central instance, server IP, etc. Okay, and then when the user is connected to the central instance keeps a track of the dialog instance, which dialog instance are alive and which dialog instance has less load. So that information is available with the central instance, and depending upon this load, that central instance will disperse the traffic to the dialog instance. So if all these are busy, it will probably disperse the load to the these dialog instance, and then the rest of the process is same. Again, it communicates with database and respond back to the user. So that is same, but the different is especially for the distributed system is that instead of configuring the IP address of the or hostname of the dialog instance directly into the user, we put the central instance details, and then central instance keeps a track of the health information or how busy each dialog instance is, if any dialog instance is alive or not, or uh, there might be a problem in this dialog instance, so it's stopped or it's shut it down, or the server is not available, the network communication is not available. So in that case, these three are available with the central instance, so it will disperse the traffic among these three dialog instance. Okay, so these works like keeping track of the health or the load of the different dialog instances, and then dispersing the um, uh, traffic to the dialog instances. This is done by message server. Okay, so that's why we are calling it as a master of the SAP system, or it it has a bird eye view of the entire SAP system, because it keeps track the load of the different dialog instances, and it can disperse the um, load to the different dialog instances based on the current load. Okay, now if you have a distributed instance, you can directly though supply the dialog instance details to the user GUI. That will also work, but in that case you will not be able to harness the power of the load balancing. Okay, because load balancing is a good facility or good feature, right? So that you can evenly distribute your system load to the available dialog instances. So if you directly put the details of the dialog instance into the user GUI, then all the all the request will redirect to the same dialog instance. It will not be routed to the um, other dialog instance based on the current load. Okay, so that is the work of the message server. It keeps track of the uh, entire what should I say, um, entire architecture of your system, all the information about all the available dialog instance, which dialog instances are available, which are down, which are not reachable, which are healthy, what are the current load of those instances. Every information is there in the central instance, specifically with the message server. Okay, and the NQ server keeps track of the logs. For example, one user is connected to the dialog instance, this primary application server dialog instance, and it is editing editing a data. And another user connects to this instance and wants to edit the same data. So if there is no common repository or common information base, how system will understand, okay, the same data is being edited by someone else? It will be troublesome, right? So to avoid that, the NQ server is here and it keeps track of the all those data which is being edited or being locked, or the log data, so that before you grant access to exclusive access to any data, all the dialog instance, I mean, whichever dialog instance is requested to give access to exclusive access to the data, before giving you the access, it always go to the NQ server and it checks whether this data is already locked or not. If not locked, first it will acquire the lock and update NQ server that, okay, I am going to exclusively lock this data for the editing, deleting, or modifying purposes. So NQ server creates an entry inside inside its system, and then it sends the acknowledged, okay, I have locked the data, now you can give the access to the user. Then user get access to the data, and then the process follows as usual. And until you save the data or you cancel the data, the lock is there in the system. If any user from any dialog instance requests the same exclusive access to the same data, then again that dialog instance will go to the NQ server and ask, I want to log this data, and immediately NQ server will tell, no, this data is already logged by someone else, you cannot log it. So this dialog instance then immediately refuse the user to give the exclusive access. Okay, so that's how NQ server serve a common goal for the all available dialog instances to maintain the um, mm, uh, what is the term I'm looking for? The consistency of the data. Okay, so it maintains the consistency of the data. If the NQ server is not available, then these operations, I mean, no operations would be possible. So these two services, one is message server, another is NQ server. These two are the major part of the central instance. It facilitates the operations of the dialog instance, though it does not perform any user request or computation for the user. It just facilitates few feature or few services to the dialog instance, so that dialog instance can perform the computation seamlessly. Okay, so we completed SAP architecture and basis roles and responsibilities. Now, let me start this topic. System monitoring and troubleshooting. So the reason I'm starting this topic first is this will give you a very nice uh, uh, go through different topics or different aspect of the SAP system, and it will give you a very basic and general idea of the SAP system, and it will also rehearse you how to use the SAP system in a quite a bit. So okay, so that's why I'm choosing this topic first, and then we will go through the topic one after another. Okay. All right. So, what is system monitoring and troubleshooting? Right now, I am only I'll only concentrate on the system monitoring, and I'll concentrate on the troubleshooting later. Um, so, what is system monitoring, and uh, what what do we mean by that, and why it is done? So, system monitoring is basically uh, checking the health of the SAP system. Okay, a system monitoring is performed to check whether your system is performing fine or not. So each day before the business hours start, let's say you are assigned in a project, and that project office hours starts at the 10 a.m. Okay, 10 a.m. to 7 p.m. This is the business hours. So what we do is we log in at least 1 or 2 hours prior to the business hour start. So probably we'll start at the 8 a.m. and we will run few transaction codes. We will log in into waste level, check few things to understand uh, whether there is any problem in the system, or in some cases we also try to understand, or we try to predict whether there would be any system in future. So there are few things, if we check carefully, it will um it will give you an idea that okay, there is no problem right now, but there might be a problem occurring in very soon. So there are few steps, there are series of steps and transaction codes which we'll execute, and then we'll try to understand uh, how our system is performing. Okay, so I'll go and execute those transaction codes one by one and try to explain what are the things we will look for into the system, and then if you have any question, just ask me. Okay, so first transaction I'm going to execute is SM51. Sorry. So one more thing, if you are if you guys are already experienced in basis more than a year or a couple of years, so for them this is quite obvious, but people who are starting just right now as a fresher, so here is the box. It's called transaction code box or command box. Here we provide the transaction codes. Okay, the transaction codes are basically shortcut to a SAP program. So SAP program, there are SAP programs designated for different works, and SAP provides a very nice way to call those programs. For example, a program name is um, Z monitor monitor application server. Okay, don't mind my spelling. Okay, I'm just trying to give you a demo. So let's say this is a program name. This is a program name. So now each and every time if you have to type this program name, it's a burden for you, right? Sometimes the program name would be even bigger than that. So to avoid that, SAP has come up with a very clever way. They basically assign short codes to this program. Instead of typing you or running you this entire program, you can just type in those short codes and it will run the program. So first transaction code will run is SM51. So this transaction code SM51 basically calls a program. The program is used to display the application server you have in your system. So you have the system A4H which you will currently logged in. It will list all the application servers and their status. Okay. So right now we have one dialog instance. So that's why one dialog instance is shown here. If you go to the OS level, you will see that your dialog instance application, sorry, just give me a moment.
Alright, let's test your knowledge. Here is a question for you. What is the primary role of the SAP Basis Administrator in an SAP HANA environment? Option A, managing the operating system. Option B, configuring the SAP HANA database. Option C, monitoring system performance. Option D, all of the above. Take a moment to think, and when you are ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comments section. Hey there, want to level up your skills in managing supplies? Our SAP Basis HANA course is here for you. Take it at your own pace on our platform. In this course, you will dive deep into SAP Basis HANA, a powerful tool for handling supply management. It's like a toolbox for planning things, ensuring we have enough products and getting them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors are pros with tons of experience. They are here to guide you and tackle any questions you may have. And guess what? Our students love this course. Folks just like you have found it incredibly helpful. What's even better, it's affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA whiz? Sign up on our page now. For more info, head over to ZaranTech's website.
Your dialog instance instance number is 01, right? So same thing you can see here also, that if you have you have this host name. This is the host name basically. Okay, if you type the command host name, you will see this is the host name or the name for the server. So if you go to the SM51 first, you will see the host name underscore the system name or SID underscore the instance number. So we have only one dialog instance. That's why you are seeing one dialog instance. If the A4H system would have 5 dialog instance, then it would be listed here. So this is basically to check if my all instances are running fine or not. Okay, so for example, if you have 5 dialog instance and you come here and see one dialog instance is in red status, it says that not available, shut down, partially running. So then you have to pay attention to that dialog instance or that server, why it is not running. But if all your applications are in active state, in green state, then you are fine. Okay. So generally what we do, we create a Excel sheet. It's called monitoring sheet. And in every morning, we generally fill this Excel sheet and send to the customer or our project manager. It depends upon uh, project to project, but in general, all the projects transaction port status. I'm just doing little formatting here. Okay, so first we have seen SM51 and the status is okay. Why it is okay? Because all the application server is active and green. So we have one application server for this system and that is active and green. So here in SM51, what is the information we are looking here is all our application server should be active and green. Okay. Next we will go to the SM50. Okay. So we'll just go to the SM50. Now if you have noticed, I have entered the transaction SM50, but it's not happening anything. It's not changing the screen or nothing. So the reason is I have already executed one transaction and I am on that transaction screen. So now if we want to execute another transaction, I have two options. One is I go back here and now I enter SM50, SM50, then it will work. Okay. But if I don't want to do that, let me go to the SM51 once again. Now I want to go to the SM50, and if I enter SM50, it will not work. So what I need to do is I need to type /n. /n means new screen or override this screen. If I then type SM50, then it will work. See, so so what I tell my student in general, you develop a habit of providing /n every time. So whenever you are executing any command, just give you a habit of sm habit of provide /n, and then if you are the beginning screen or the home screen, then you can avoid it. But otherwise, you can develop a habit of it. Okay. All right. So now we are at the SM51 screen. So here you can see that there are certain list. Okay, and the list is about the work process. So this is also our architectural topic of the SAP system. As I told you that we will hit the topics in between, and whenever the topic comes, I will explain about these topics. Okay. So now let me tell about the work process. Okay. So if I go to this just give me one moment, guys. What I was telling about is this is the dialog instance, right? And in the dialog instance, we can see there are 4 executable files running. One is dis plus work, IGS, GWRD, IC1. Okay. I'll explain each of those topics when the topic comes. Right now, it is about the dis plus work process. So when we talk about the dialog instance, we always say that okay, dialog instance does all the works. It receives the user input, it does all the works, it reaches to the database, it gets the data, calculates and respond back to the user. So who does all this work? It's the dis plus work process. Dis plus work process. Okay. So this work process basically does all the work. Okay. Now, if I see this thing in the OS level, let me execute the command. Okay, here you can see that this plus work process is running several times. Okay, so these are the instance of this process. So the process is not running one time. Multiple instance of that process is running. Okay, multiple instance of that process is running. So why it is so? It is because, just a minute. Okay, so multiple instance of this process is running this plus work process. Okay, so that is because the if you have the SAP system, obviously multiple users should be connecting, right? And that users basically looking to connect to the system to execute some um, transaction code or any particular task. So what it does is it create multiple instances of this display process, and so that if multiple requests comes at the same time, it can respond to the multiple user at the same time. Okay, so here you can see that this is basically manifestation of the same work process. It basically multiple instance of the same work process, same process, and these called work processes. So it is just this plus instance of the this plus work process. So what is the total number of the work process is 33. So 33 number of work process is running. So these work process are manifestation of the this plus work. Okay, so the same executable is running 33 times in the system. Okay, so but all these 33 work processes are not doing the same thing. There are different types of work is being done by these work processes. So among these 33, there are 20 work process which is called dialog work process. Okay, let me write down here. So dialog work process. Then we have BTC. Uh, this is the code. Then we have BTC, that is background work process. Okay, so here we can see that there are around 10 background work process. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10 work process. Another is UPD. This is update work process. Then this is pull work process. Also UPD to update. So though they are the same this plus work, but they does different kind of works. So dialog work process is basically the user interface. So they basically handles the user communication. So I am executing this command, right? For example, I have executed this SM51 command. So definitely it went to the it went to the dialog instance, and dialog instance assigned a work process. So this is the work process I have been assigned. If you go to here, you see my ID ZBasis1. Okay, so if you see, I am the user ZBasis1. So basically, I have been answered by this dialog work process. I have been assigned to this dialog work process, and it fetched these data from the database and responded to me. Okay. So dialog work process, basically the work process which gives output to the user. Then what is background work process? Background work process are the work process which runs few programs in the background. So for example, right now I am executing few T codes, okay, and it is giving me output. So that is happening on the real time. I am giving the output and I'm expecting some, I'm giving the input and I'm expecting some output. So that is the dialogue execution. But sometimes there are programs which will handle or which will work on very large amount of data set. So at that time, the program will be running for several hours, in some cases several days. So at that time, we cannot execute a program and wait for in front of the screen for several hours or days, right? So in that case, what we do, we run those programs in the background. So we fire the program and we exit from the screen, and then program keeps running in the background. And at the end of the execution of the program, it produces the output which can be accessed or it can be seen later. So those kind of execution of the programs, that is done by the background work process. So it is suggested that you have at least 2 background work process and you have at least 2 dialog work process. Below that, there might be a problem. But it depends upon the system uses, whether you have more number of dialog users, or you are using system for any computation purpose where you have very low number of dialog users, but your background jobs are way more. So in that type of cases, this number varies, but in general, the rule is not in general. The rule is you must have at least 2 work process dialog. All right. So this is about the dialog and the background work process. Then we have this spool work process. Spool work process is basically for printing purpose. So if you want to print something out of the SAP, then those outputs redirect to the spool work process. Then from that spool work process, the printer is called or connected and the data is transferred to the printer for the printing purpose. So that kind of work is done by the spool work process. So as people generally does not print huge number of prints, or this is not very frequently used, so only one spool work process generally should be fine. And then we have UPD and UPD2. These are the update work process. So whenever you have a large chunk of data updation in the database, then instead of using this dialog or background work process, the data is basically transferred to the update work process, so that the updation can happen without occupying this dialog or background work process. It can happen independently. Okay, so that's the use of the dialog work process and update work process. So we have 5 kind of work process. One is dialog work process. This is typically for user communication purpose. User, whenever connected to the data dialogs instance, it is basically assigned a dialog work process, and that dialog work process does all the work for him or her. Okay, background work process is for the running background jobs. When we run any program in background, one of these background work process is occupied, and it runs the program and prepares the output. Okay, and then we have the spool work process for printing purpose, and update work process, two kind of update work process for the database updation. Okay, so these are the work processes. So now we have understood the work process, different work process and what it does. But when we are doing the system monitoring, what we are going to looking in this screen, that is the status of the work process or work process status. So if you see waiting, that means these work processes are free. These work processes waiting for the user to instruct them, or waiting for the user to do some work. So if your system having maximum or most of the dialog work process free or waiting status, that means your system in good condition. Okay, that means your system is not overloaded. We have here 20 dialog work process. If we see more than 10-15 dialog work process are free, we can assume that our system is good. Okay, but if we see among 20 dialog work process, 18 is already eaten up, 18 is in running condition, or 15 is running condition, then we have a problem. Very soon we might run out of the dialog work process. If that happens, whenever the user connects for login or any transaction code execution, they might get a rejection message or a error on their screen. So that is not good for the systems, at least for the production systems where business is running. So here what we look for, maximum number of the dialog work process should be free, or any work process should be free. If you have 10 BTC, at least 50%, 60% BTC should be free. If you have 20 number of dialog work process, at least 50-60%. I mean, if you have 20 work process, at least 10 to 12 should be free. Then you can call it good. Otherwise, not. So in SM50, what we look, most number of work process should be free. Now in our cases, yes, it is free, so we'll write down okay. So there are more than 10 to 12 this kind of transactions which we generally execute as a part of the system monitoring. This gives us an idea that okay, our system is in healthy condition and there is no upcoming challenges, or there is no upcoming problem we can see. At least we cannot see right now. There might happen, that is fine, but at least before starting the business, when we go through the system, we can understand whether there is any problem or not. Okay guys, so I'll stop the session as of now for today here, and tomorrow we will learn about other transaction codes which we execute as a part of the monitoring, and then we will practice those transaction codes, so that you have some hands-on and you don't hesitate while do the monitoring. This is very crucial for you if you want to build your career in SAP Basis. Then monitoring is the very important thing for you. The two reason behind that: one is it gives you an overall idea about your system. It gives a very nice idea about your system, where to look for what information, what are the things you need to keep in mind to your business running. That is one thing. Uh, second thing is, whenever you are assigned to a project as a fresher or as a junior consultant, this would be the first thing you will be asked to do, or this is the foremost expectation team lead or your senior consultants will expect out of you, that you monitor the system and you are able to understand whether system has any problem or not. So that's why please pay attention carefully on system monitoring. uh, I hope most of you have got the access. If not, especially for the network issue, please raise the ticket as soon as possible so that it can be fixed by today. Raise a high priority ticket with your network team. If not possible, then if possible, if you arrange your own personal laptop, then also it is fine. But please get your network issue sorted by today so that tomorrow you can do some hands-on. Okay. So first of all, we learned about what is SAP. SAP is a collection of software which is help organization to manage their resources, whether it's a financial or humanitarian. So it's basically the collection of software which is helps organization to um, manage their resources. Okay. So SAP has a very vast field, and one person or uh, 2-3 person cannot manage it in general. So what they did is they divided the similar kind of works in different segments or modules. Okay, so few peoples will be dedicated to programming, who will developing new features and all. Few peoples will be managing the servers and services. Few people will do finance related stuffs. Few people will do sales related stuffs. So these are the segregation based on the application and based on the usability. So those called modules. We are focusing on the SP basis part. The role of the SP basis is to commission new system, installing new systems, patching a system, upgrading a system, migrating system to new hardware or new technology, OSDB technology. Also, our job is to troubleshoot the system if there is any platform related issue or software related issue. When to troubleshoot it, and if there is any issue comes, user complaining about any issue. So at that time, we also need to troubleshoot the issue and identify the issue, and if it comes into our bucket, we need to resolve it. If we find that okay, this is not something basis issue or platform system related issue, this is some configuration issue, then we pass it on to the related team. Okay, so that's our job. Then we discussed about little bit of the NetWeaver architecture, that it works in a 3 layer. Um, One is presentation layer, which is our screen. When we see the screen, uh, and none of the data storage or data computation is happening on our screen. Only it's being presented. So that's why our screen is the presentation layer screen. Presentation layer. In between there is a data application layer where all the computation is happening. Basically, this layer is receiving inputs from the user, and it's deciding whether it needs any further data from the database or not. If yes, then it is getting the data from the database, doing the further computation and responding back to the user. So that's the job of the application layer, and database layer job is to store the data. Now these 3 layer can be achieved different in different way. Okay. So um, so one of the way is to having two different servers. One is for database and another is for um, application. Okay. So in one server you install application, and in another server you uh, install the database. Or if I if I talk more practically, in this database server, we generally only install the database software or the database executable file and run the SAP installation in application server. So what the installer, SAP installer does is it installs all the SAP here and it creates a communication channel or a connection settings to connect to database server, and it pushes all the data to the database server. So this is happens during the installation. So after the installation, the system is built like that way. So the data is stored in the database, and whenever required to push or pull the data, it happens through the network. So this is called multi-tier architecture or three-tier architecture. Especially for this case, it's a three-tier architecture. Also, you can call it multi-tier architecture. I mean, other kind of design, you can put the apps and DB in the same server. It is fairly possible if the system load is not very high, you are not running heavy load, the user base is low, then you can put the two things in the same server. In general, what we see for ECC, BW, we generally see multi-tier architecture, but systems like SRM, Solution Manager, um, gateway system, these kind of systems, generally we have seen that it is built in the two-tier architecture because it's a kind of helper system. It does not have very much it does not generally generate huge load. So in general, we see this kind of architecture for those two systems. This is how SAP, I mean, this is the architecture of the system installation, how you commission your entire system. Now, this is more about the um, internal architecture of the SAP system. Okay, so there is a concept called SAP instance. SAP instance is a building block of the SAP. So one SAP system is comprised of the SAP instances. Okay, so each and every system will have a three-letter system ID or SID. USR SAP is the SAP installation directory, and in the directory you will see these folders H4, MJ1. So these are the SID folders. So for each system there would be one SID folder under the USR SAP, and SID is decided when system is being installed. When we will do the system installation, you will see that we will provide the SID. It has to be three-letter, cannot be more or less, and it must start with a letter. It cannot start with a number. Okay, so under each and every SID, if I go to A4H, you will see three directories, three significant directories. One is ASCS, and then D01 sys. So this is for the client, HANADB client, as we are using HANADB here as a part of the S4HANA system. So this is just a client. We can install it here or any other place, doesn't matter. So this is not very significant. The significant three things is here. So one is sys. The sys contains the kernel. Okay. So what is kernel? Kernel is basically collection of tools and executable files, which is heart of the system. So whatever SAP runs at the base level, whether it's a service, it's a server, it's a executable file, all they are in the kernel. So it's part of the kernel. So if you go to sys folder and you will see further directories, uh, inside exe directory kernel is present. So we'll travel through more directories, but and then you will see further directories inside that. You'll pay attention to these two folder UAC, UC, and NUC. This is basically means Unicode or non-Unicode. So if your system is Unicode, during the installation you have to basically choose whether you want to install Unicode or non-Unicode. So nowadays there is no non-Unicode platform is available or system is available. It used to happen a couple of years ago that you could have choose Unicode or non-Unicode. Unicode, non-Unicode means is the representation of the character in the system. So whenever you write anything in the system and it is stored in your database, so in what format it is getting stored in your system, that uh, depends on whether your system is Unicode or non-Unicode. So if your system is Unicode system or Unicode compatible system, then all the character, all the data, whichever you write or save, will be stored in a Unicode system. And if a non-Unicode system, that then it is not stored in the Unicode format, it is stored in some other format. So major benefit of the Unicode system is it can store, or it can represent, or it can describe a larger set of the character. Okay, for non-Unicode system it was very limited, a small character ABCD plus capital ABCD, then few symbols, plus minus. So it was very limited. But in case of Unicode system, it includes lots of asterisks, lots of special characters, symbols, emojis, and lots of other language also. For example, Hindi, Bengali, Tamil, Telugu. So these also can be stored very efficiently using the Unicode system. So that's why SAP moved to Unicode system, and now you cannot find anything which is non-Unicode in the SAP system. All right, so that is a little bit introduction about Unicode, non-Unicode. Occasionally uh, you might face some or you might encounter a non-Unicode system, and probably you will also get some chance to non-Unicode to Unicode conversion. But this is not topic of our course. Just this is for your heads up that yeah, non-Unicode system is still there. Maybe very old systems are still there. So yeah, so now this system is S4 HANA system is not available in the non-Unicode version. So definitely the kernel should be in Unicode. So now in this folder, what we see, this folder is um, uh, tells us the OS version. Okay, so we have Linux x60. This is the chipset family, and this is a 64-bit version. So this OS is Linux x86 64-bit. So that's why we folder name is like that. If we are checking in our Windows folder, we will see here a Windows related directory. I mean, the name should be Windows x64, something like that. Uh, we'll go into this folder, and here you go. So these are the files. When we see the instances, we will see that these executable files will run in the system. Okay. All right, so we are in the sys folder. This is very significant folder for us. Under the SID directory, the folder is sys. In this folder, mm, the kernel is present. And when we do the kernel upgrade, we basically upgrade in this folder. We will create a copy of this folder as a backup, and then we will probably delete these files and paste new kernel and start the system. And so if I go back to this SID folder once again, you see that there are other two folders. So these are the instance directories. So what is instance? Instance basically a building block of SAP system. Why it is so? Because SAP without instance there is no existence of the SAP system. This is just a storage. Okay, it won't do anything in the system. It will just hold the kernel file, but this is not doing the actual job is done by these two folders. So what are these two folders? These folders called instances. Okay, so the uh, major part of these folders are it will hold a copy of the uh, exe files or kernel. Okay, so when the system is started, it will basically sync a copy in these two folders. It will push the files in these two folders. Okay. So if I quickly go into this folder, you will see that there are different directories. All of these directories are significant directories, but I'll explain these things when we'll do the troubleshooting. Now, for the time being, let me go to the exe folder, and if you'll see that a copy of the kernel is there. So it's basically when the system is started, it sync a copy in the in these two directories. So what happens is after the system is started, basically it will start few of this execute few of these executable files, and it will create the service, and that service is basically the SAP. Okay, so um, when you talk about SAP, is basically the service is running in the west level. We can connect from the remote, and we do all sorts of work. So that is basically these files are running, and it responding to the user and doing all the work. Okay, so uh, that is the instance. Instance means executable files at the west level running in the system. It consumes some memory, consumes some RAM, consume other hardware resources, and it is running as a service, and it is providing providing um, response to the user, or do all sorts of computation and communication. Okay, so now here you can see there is two folder. Okay, one is ASCS and another is starts with the D. So ASCS means central instance. This is for the central instance. So, and this is for the dialog instance. So what is the significance of central instance and dialog instance? Central instance basically does the communication between dialog instances. So before that, let me give you a little introduction about the dialog instance. So dialog instance basically do all the dialog stuff. Dialog means which happens on our screen. Okay, so the reason it called dialog instance is basically it it receives user request and is do the computation if requires, is connect to the database, and then it respond back to the user. Okay, so all the communication, all the um, calculation, all the work is done by the dialog instance only. Okay, so the so that's why this is very important, that when we do all kind of troubleshooting and all, first we check this status of the dialog instance. Okay, so dialog instance is basically responsible for taking user input, go to the database, get the data, do the computation, and respond back to the user. So that is the major work of the dialog instance. Now, in the system, there could have multiple dialog instances. It is quite normal that we will have 2, 3 dialog instances. If the system is heavy, big enough, user base is big, then we will have multiple dialog instances. But you must have one minimum dialog instance. Otherwise, uh, the system will not work, right? Because who will then respond to the user? It's not possible. So you can have multiple dialog instances, but only one is absolutely required. Then we have the central instance. The central instance basically is a brain of the SAP system. So what it does is it manages the intercommunication. If you have multiple dialog instance, it will manages or keep a track of the status of those dialog instances, and it will maintain the data consistency, and it will maintain the interconnectivity of these systems. So when I'll be let me explain it little bit more broader way so that you understand what I'm saying. So right now, okay, let me change user to SID. Okay. So right now I have executed a command. I'll ping in your chat so that you can keep a note command. So this is the SAP control command. This is part of the kernel. SAP control is part of the kernel, and we want to see the information for the instance 01, which is our dialog instance. Uh, this is the parameter for the instance number, and function is get process list. So we want to see the process list for the instance 01. So when we execute that, we'll see there are 4 processes running. One is this plus work, another is IGS, and another is gateway, another is ICM. So we will see this. We will see this in detail later, but for the time being, we are concentrating on this only. Okay. So here we can see this plus work process. This is the above dispatcher work process, and what it does is it basically collects the user request and distribute it to the work processes. So what is work process? Work process is nothing but the manifestation of this plus work. So there would be multiple instance of this plus work process. This plus work is running in the system, and these basically doing the all sorts of works. Okay. So when you execute a transaction code, basically you talking to the this plus work, and it is getting connected to the database, and it is doing all the computation. So that's why so this is one key point to note. Whenever you are doing a troubleshooting, you are starting a system and you see that your central instance is running, everything is running, only this plus work is shutting down, or it is going into yellow state. It is not getting green, and after 10, 15, 20 minutes, and it is shutting off gray. So your first checkpoint would be the database, whether my database is running or not, it is accessible or not. So for that, what we do, we run a command called R3 trans, R3 trans -d. So if you do that and you get the output 000 or 0, then you understand that okay, my connection to the database is correct. Okay, I'll pick this command also. Let me pick this one. Check database connectivity for above systems. So remember, guys, this only works for the above system. This does not work for the Java systems. So now we see that our database connectivity is correct. So whenever you are running this command, log file is generated. So right now where I am, if you execute pwd, I am in the home folder, then my A4HADM folder. So here uh, trans.log file will be generated. As soon as you execute this command, a trans.log file will be generated. Now you can read this file for the details. Right now we have 000, so we will not see any issue. But if you get RC4, RC8, RC16, RC200. So in that case, these log will be very helpful to you. Okay. So here you can see all very in detail of the database connectivity, like what are the things it is getting loaded, how DBSL library is being used to connect and everything. Okay. So yeah, so this is the way to check. Okay, so I was talking about the instances, right? So so here is the most important process for the dialog instance. If this is down, anything will not work. You will not be able to connect to the system. So now we have seen the importance and what is the dialog instance. And now let's look at the central instance. So here in the central instance, you see two important service. One is message server, and another is enqueue server. So when we were talking about the central instance, I told you that the intercommunication or interconnectivity is being done by the central instance. So inside the central instance, there is the message server. It is actually the interconnector. So inside the message server, inside the central instance, this service is the main brain. So what it does is it keep tracks of the dialog instances. So if you have 4 dialog instance, so it will keep track of the health of the dialog instance, how it is doing. Is it all 4 are up, or if there is any one not fully up, partially up, one is down, um, or what is the current load of them? They are running under heavy load, or one of them is not that much clogged up. Okay, so all those kind of information, or the uh, information about your entire recipe landscape. So entire recipe landscape means I'm talking about only that system. It's not other systems. So the entire landscape of that system, whether it is having multiple dialog instance or not, so entire thing would be um, the entire information would be available to the message server. So the benefit of this is, if you have multiple dialog instance, instead of mentioning dialog instance IP in your SAP GUI, what you do is you mention the details of central instance. I mean the IP of the central instance and instance number of the central instance, and you configure the load balancing here. So then what message server does is, uh, once the user hit the message server, it basically routes the traffic to the less busy dialog instance. So it has all the information of all the dialog instance, which one is very much busy, which one is not busy, which one is less loaded. Okay, so according to that, the message server basically route the traffic to that dialog instance. So that's how load balancing is achieved, and so you get a better performance out of your system, right? Otherwise, uh, if you mention the IP address or the hostname of the dialog instance directly in your um, uh, SAP GUI, so no matter whether your dialog instance is busy or under heavy load, it will definitely go to that one only, because there is you mentioned direct address of that load balance dialog instance, right? But if you mention this message server details, you hit to the message server has all the information which one is not under heavy load, and it will redirect to according to that. One more thing is this enqueue server. Enqueue server is basically keeps it handles the locks basically. Okay, so whenever let's say you have requested to change a data, and that data is system is allowed you to change the data, and you are now in the edit screen. You are basically and you are basically changing our data. So in that time, NQ server will keep a track that, okay, this data is being edited. So when it is being edited, if another person wants to work on the data, it will give you an error message that this data is being worked upon, you cannot edit this data. So where the system is uh, getting information that this data is being worked upon. So this is basically from the NQ server. So whenever you are requesting any data for exclusive access, like you want to delete it, you want to edit it, you want to change it, so before allowing access, it all the dialog instance basically goes to NQ server and checks whether there is a lock on this data or not. So if the NQ server respond, okay, I don't see any lock, then only it will be allowed for you to change. Otherwise, if NQ server has a lock, it says, no, I have a lock on this data. Dialog instance will immediately respond back to you that this data is not available for the edit. Okay, so that is the work of the NQ server. Okay, so again, the instances are basically uh, the building blocks. Why? Those instance will do the job, and there are two type of instance. One is central and one is dialog responsible for the user communication, computation, and the data read, write, and everything. Central instance is responsible for the internal work of the SAP system, what it manages the interconnectivity and the um, data integrity. Yes. So the data integrity is maintained by the central instance, so that the data is not edited or it's not changed by two people at the same time, so that data become inconsistent. All right, guys. So that is the concept on the instance. Here is the same thing which I was talking about. So previously, we had this central services instance where the message server is placed, and in the central instance, NQ server and gateway process. But now it is merged with the central. These two merged, and it became the central instance. If you see the systems which is very old, not upgraded, you will see these two instances. One is central instance, another is central services instance. But if you are seeing any system which is commissioned in last couple of years, 5, 6, 7, 10 years, will not see this instance. You will see only the central instance, and message server is moved in this server central instance. Okay, then we were talking about the distributed system and single instance system. So as I told you in couple of slides earlier, that you can install the application and the database instance in the same server. So it's called single instance system. And if you have the application server and database server separately in other box altogether, then it is the distributed instance. Now it can you can distribute your SAP landscape further by using some additional dialog instance. Okay, so uh, you have your uh, application server where you installed your central instance and the dialog instance. Okay, so here you have your SAP system where you have installed central instance and dialog instance, right? And then you have your database instance. So these two are self-sufficient. But now your requirement is big. You have large user base, one dialog instance, or let's say you have added one more dialog instance here. Okay, one more dialog instance here, but it is not able to cope up with your requirement. You need more. So what you can do, you can create another server, and in that server you can add two more dialog instance. okay, or 2, 3, whatever you like, dialog instance, and it is connected to the central instance. So you will run the SAP installer here, and it will ask for the uh, central instance detail. You will enter the central instance details, and then it will install dialog instance here. So it will work along with this system, and it will you can achieve the load balancing using central instance, so that some of your load is redirect to here, and from there it will talk to the database and respond to the user. So this is also like you are leveraging uh, the benefit of the application distributed instance even more. Here you are only doing the database instance and the application instance separately, but here you are even uh, leveraging the benefit of the distributed system even more by creating two another server which will only dedicate to the dialog instance. So uh, so basically it will give you more power, it will give you more robust system. Okay. All right, so this is all about the architecture of the SAP system for the time being now. As I told you, there are many more things to describe in the architecture. So what I do is, instead of prolonging this architectural discussion, which is not any you are not doing any hands-on. So without doing that, what I do is, whenever I go through the topics, um, I go through these topics, I pinch in little bit of architectural discussion in them also. So whenever I'm doing this these topics, whatever the topics which is related to these topics, I mean architectural topics, I will then push those topics inside, so that you will keep building knowledge on the architecture, as well as you keep doing this hands-on. Okay. All right. So do you have any question regarding this? Um, regarding this architecture which I discussed so far? Anyone? Can you please share your screen and prepare the monitoring sheet? Okay. So just insert one row on the top. Yes, you can write as a T code, and in the second column you write status. This is a very minimized version of the monitoring sheet. Uh, so project to project it varies. In some project you will see that uh, very extensive version of this sheet, where you will have all sorts of um, uh, information which you need to check. But yeah, I mean, in if you talk about the gist, so these are the things we generally we what we need to check for those transaction codes. Okay, so let's see. So before that, I'll let me give you a little introduction of the monitoring, why we do that. So generally, monitoring is done before business hours starts. Okay. Okay. So the reason we do monitoring is to understand whether there is any system problem exist or not, or in some cases it allow us to identify the issue in quite advance. Okay. So for example, we see the uh, disk space is very minimum. I mean, if you do the monitoring here, let's say I'm doing the monitoring here. Okay. And as a part of the monitoring, I'll um, execute the space command. So let's say we are doing monitoring, and in the morning, our business starts at 10 a.m. and it runs through uh, the day and ends at 8 p.m. Okay, now we are doing monitoring at 8 a.m. and we are seeing that our USR SAP is almost filled up. So here you can see it's only 8% used. But if we at the morning, if we see it's only 2% free. So what will happen at certain point of time during the day? It will be 100%, and there would be no space left on the waste level, and all the logs generation, all the file generation at the waste level would be stopped, and our SAP system immediately will become unresponsive, right? So that is not what we want. The business will be stopped immediately. So if we identify that, okay, we have very less space available in the waste level, so we can do two things. One is, if there is an unnecessary file, we can delete and create some space. If it is not possible, or there is no unnecessary file at the waste level, we cannot free up space, we can immediately talk to our waste vendor and say that, okay, we have the problem, the waste space is getting filled up, can you please add some space quickly? So they will add some space, and then your SAP system is out of the risk. So in that case, what we see that we identified the problem quite early. Even the problem occurred, we identified there is a problem which is about to happen, and we avoided it. So that is one aspect of the monitoring, that identify the problem forehand before the problem actually occurs. And second is, if any problem happened, uh, so then we can take the respective measures uh, to rectify those issues, or compensate those problems. So you can take corrective measures. For example, there is a critical job which is runs every night at the 12 a.m. or 1 a.m., and in the morning you have seen that the job got failed, and the job belongs to HR department, and it processes the salary. So you can immediately inform this to your HR consultants, and they will probably assess the situation and impact, and they will come up with a solution. Probably they ask you to run the job again, um, uh, or um, they can plan the job later also. Also, if you have some other problems which we'll see in a bit, then you can do the corrective measures, that what you can do. Okay, so that is the primary goal of the monitoring. One is to identify if there is any problem happened. Another is to forecast the problem. So if there is any problem which is about to happen, and if we can identify that, that would be very good. Okay, so first we will be checking about SM51. SM51. So here we check the status of the application servers. So in every transaction code for the monitoring, I will tell you what you should look for in the screen. Okay, so that you exactly know that what is the red flag and what is the green flag in the monitoring. So here, this is the green flag. So you will check the status should be active and green. Okay. So in this system, we have only one dialog instance. So in AS instance of the system, I mean list, it will show only the dialog instance. You go to the SM51, it will show you the dialog instance. So if you have 5 dialog instance, it will show 5 dialog instance here, and all should be active and green. If not, then you will go to that dialog instance waste level, and you troubleshoot. You need to you need to execute this command to see what is wrong with it. You execute this, and so you can have the detailed information, like which are the processes not running, and then you need to troubleshoot accordingly. Okay, but if you have this green and active, so you are good. Okay, so now we have checked this, so we will say this is okay. Then we will go to SM50. SM50 is the work process monitoring. So when we are talking about this dialog instance process, we see that these plus work process, right? So these basically do all the communication with user and computation. So these are the dis plus work process running in the system. So you see there are number of dis plus work process. Total is 33 is running. So why this number of work process running? Because if you have only one, then what will happen? If that is busy, so the further users will be rejected, because there is no work process is available to serve the user. So that's why multiple instance of the work process, this plus work process runs in the system. And in this case, we are running 33 work processes. Now, all the 33 work processes does not do the same thing. There are 5 segments of these work processes, and those 5 categories work process does dedicated for different things. The first one is dialog work process. These work process basically processes the dialog or user inputs. So in the system, you will see that dialog work process are more in the number compared to any other work process. So most of the cases you will see 70 to 80% or 60 to 80% work process are dialog work process, because these basically respond to users. So whenever any request comes from the user, it basically assigns a dialog work process. Here I have run this SM50T code, and you see that this is my user, and I have also assigned a dialog work process. But don't think that I am holding this dialog work process. It's completely free. But when this information was gathering in the system, that time I was actually running this. So this is why it's seeing running. But uh, as soon as the computation is end and the result is sent back to the user, that dialog work process getting free in the system. So it's not holding up. Okay.
Alright, let's test your knowledge. Here is a question for you. Which of the following is a common task for a SAP Basis administrator in an SAP HANA environment? Option A, managing user access and authorizations. Option B, performing system backups and recoveries. Option C, optimizing database performance. Option D, all of the above. Take a moment to think, and when you are ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comments section. Hey there, want to level up your skills in managing supplies? Our SAP Basis HANA course is here for you. Take it at your own pace on our platform. In this course, you will dive deep into SAP Basis HANA, a powerful tool for handling supply management. It's like a toolbox for planning things, ensuring we have enough products and getting them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors are pros with tons of experience. They are here to guide you and tackle any questions you may have. And guess what? Our students love this course. Folks just like you have found it incredibly helpful. What's even better, it's affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA whiz? Sign up on our page now. For more info, head over to ZaranTech's website.
And then we have background work process. These background work process basically do the it uses to run the program in the background. So if there are few programs which runs it takes very long time to finish, and also there are programs which runs in the very odd times, like 1 a.m. in the morning. So those needs to be executed without human intervention. Otherwise, we will sit at the 1 a.m. in the morning to run those, right? So there are provision in the SAP system where you can schedule a program so that it run automatically at a certain point of time, and it prepares the output for you. Okay, so those program runs using this work process. Then we have update work process. This is used to update the database. When we have the bulk number of data change in the database system, these work processes are used. So there are two kind of work process, update work process. One is update 1 and update 2. And then one another is pull work process. This is basically used to print something out of the SAP system. So when you print anything from the SAP system, the data is sent to the spool work process. If spool work process connects to the printer and it's fire the print command and send back to the data to the printer. Okay. All right. So in the SM50, what we will see? We will see maximum work process are in the waiting status or not. So that is our goal. If maximum work process are in the waiting status, that means these are free. It is running means it is doing some work. But if it is free, then our system is in the good condition. So what is the benchmark? The benchmark is at least 50 to 60 percent work process. If it is free, then the system is in good condition. You have nothing to worry about. But when it is getting below 50%, around 30 to 50, you have to closely monitor your system so that if there is any bottleneck, you can troubleshoot. But if it is below 30%, then you have a serious problem. Then um, you need to check the problem in with more uh, attention and more importance. Okay, but if it is greater than 50% work processes are free, then you are good to go. So we have dialogue 20 dialogue work process. So as per the benchmark, um, if more than 10 dialogue work processes are free, then we have nothing to worry about. Similar goes for the background work process also. If more than 50% background work processes are free, then it is fine. Okay, guys, the benchmark which I'm telling you, this is not anything standard. First of all, it is very person to person, um, but the range quite similar, uh, which I'm telling you. But it depends upon the consultant. Some people will say no, 60%, more than 60% should be free. Some will say more than 40% will be free. So it is something which uh, you will understand with your experience. But for the safe zone, I can say around 50% workforce is free is good. Okay, and also in some cases the project will have this kind of benchmark. So if that is the case, then you will have to follow that benchmark. In some cases, probably the project will uh, define a number. If project had this kind of definition for the um, a system load definition, then you have to follow that. Okay. All right. So what we can say, if the maximum number or more than 50% work process is free, then we can say our system is in good. So we can say this is also okay. Uh, all right. So this is SM66. So SM66 also same. Let me tell you the difference. SM66. So here also you can see the work processes. The only difference of SM50 and SM66 is in SM50 you will see the work processes for the instance which you are logged in currently. So if you have multiple dialog instance, say you have 3 dialog instance and you have logged in into a dialog instance and you execute SM50, so you will see that in work process for only that dialog instance. But when you are doing monitoring, if you have multiple dialog instance, you should monitor all the dialog instance, right? So if you go to SM66, it will show you not only the dialog instance which you are logged in, but also other dialog instance. So here you can see the dialog instance identification, where this is your host name, this is your system ID, and this is the instance number. So SM66 and SM50 are same if you have only one dialog instance. But if you have multiple dialog instances, then probably you will look, it is better to look SM66. So we checked SM50 also, it is fine. Now we will see the SM12, which is log entries. Okay. In the log entries, what we'll do, we will clean all the filters because we want to see details for the all clients, and then we will see the details for the uh, all users, all table, or everything. We want to see everything. So right now there is no lock. Okay. So we don't have anything to worry about. But let me put a lock and let me show you. Uh, let's say I will edit this user. Okay. So now I'm in the edit screen. So what happens as soon as I requested the data to edit? Right now I'm editing ZBasis user. So these users are stored in a table called USR02. USR02. Okay, this is the table name where the table is stored. So when I'm clicking the edit, it will not immediately grant me access. First, it will go to the NQ server in the central instance, and it will ask that if there is any lock for USR02 with argument ZBasis02. So NQ server will check its internal table, and you will see no, there is no lock for the USR02 with argument ZBasis2. So you can allow. Okay. So the dialog instance then respond back to the uh, NQ server. Okay, I'm allowing this request or this data to lock, so to edit. So you can put a lock on this data. So then NQ server will create a lock entry with the argument ZBasis2 for this table. Okay, and then we will be able to edit this. And unless we exit from this screen, nobody will be able to edit this data. So now if we do the search, then we will see there is one lock. Okay, you see that for the client 000 ZBasis, I mean, I have put the lock. This is the lock owner, and table is USR04. Okay, sorry guys. So I was talking about the ACC system. In the ACC system, the table name is USR02. In S4 HANA, it is USR04, and argument is ZBasis02. So this is the data I have locked, and this is the table name. Okay. Now, if we go to another screen, and if I try to lock it here, it says that it is already locked. Okay. So now when I'm clicking this again, it is going to the NQ server and asking, I want to lock this data from USR04. Then NQ server is telling to dialog work process is, no, this data is already locked, we cannot lock. So then uh, the dialog work process is generating this error and responding back to me, and is not allowing me to edit the data. So that is how it works. Okay. Okay, so now what is our take on this SM12? Our take is, if the lock is 1 day or 2 day old, then it is fine. There is no need to worry. Or if it is 24 hours old, there is no need to worry. Probably this is actually being worked upon. But if you see a log from 2 days, 3 days old, 4 days old, 5 days old, so probably that log is not required anymore. Why? For example, I'm working on this screen now. All of a sudden, my network connectivity gone. I am disconnected. So in that case, those transaction will not end the way it is supposed to be. It is interrupted, right? So in that case, the user not working on the data anymore, but log stays in the log table or NQ log table. So that is the problem, right? It is not supposed to be like that. Uh, so right now I have this lock acquired, and I'm working on this screen. As soon as I'm out of this screen, the lock should be removed, right? The lock should be removed. But in some cases this does not happen. Let's say I was working on this, and all of a sudden my connection gone, and my laptop shuts down. So in that case, there is no back triggered, or there is no there is no back or save is triggered. So in that case, locks remains in the system. So that orphan lock is a problem. Anybody else which is legit will not be able to work on that data. So our job is to monitor the logs, and if the logs is too old, then we will what we'll do will we will not delete the log immediately. That is never recommended, and I want to categorically warn you, if you delete the log without proper measures, it will create a huge problem, so huge that you need to scrap your production system and restore your old database backup. It can have that much serious incident. So never ever in production system select this and execute delete. Never ever do that. So what you will do? So if you see here, this lock it occurred today's date, on today's date only. So there is nothing to worry. But if you see this lock is existed from 2 days earlier date. So it is already 48-year old. So what you'll do, you'll take a screenshot and you will see this user, you send a mail to this user that, okay, I have a lock on your name. Are you working on this or not? So the user says, okay, I am working on it, don't do anything. So then you ignore it. And if says, no, I am not working on it, and probably this is an orphan log, so then you delete the log with your customer permission. Obviously there would be a contact point for the basis in your customer side. You contact him or her and say that we have an orphan log, can we delete it? If customer says yes, you delete, otherwise don't touch it. If you don't have any technical person in your customer side, then at least you have to inform your team lead or manager. Guys, do not take this upon your head. So there are during this training, I will also warn you the situations where things could have gone wrong. See, basis people have very raw access in the system, very raw access, unlimited access in the system. That's why we have seen time by time lots of disastrous things happens by the basis people. Okay, that is one is you are not cautious enough, another is you did not receive proper education or guideline how to manage the risk. Okay, so I'll try to give you maximum awareness of the risk. What are the positions where basis activities could do mess in the system? Okay, so this is one point. I have seen people deleting the logs without doing the proper measurement. That is absolutely wrong. Never ever do that. At least it should not come upon your head. You inform your customer, you inform your team lead. If they approves, then only delete it. If anything happens, this is on their head. At least you are clear. Okay. All right, so we don't have any logs here, so it is good. Okay. Then we will be using monitoring users, SM04 or AL08. So let's go to the SM04. Uh, it will show you the current logged in users. So right now I see ZBasis 0, ZBasis 2, 14, 13, 8 is logged in. So sometimes you need to see this list, especially when you are doing any maintenance activity. You probably you want to lock the system so that you do the maintenance activity, and you don't want anybody to log in into the system, or you want to um, uh, you don't want any change, any data change in between the system. So this is happens especially when we do any a system upgrade, patching. At that time we don't anyone to log in and change in anything in your system, because that can generate system data inconsistency. So what we do is we log into the system and check SM04. If there is any user logged in, we simply select them and we kick out of the system. So here we uh, see log of user, and we select system wide. It will be automatically logged out. He will be automatically logged out. Okay, so that is what we do in the SM04. Again, SM04 is only for the uh, only for the instance which you logged in. But if you go to the AL08, you will see that users from the all your instance for that particular system. So here you have seen in case of SM50 and SM66, right? So using that, you see all the work process for the all dialog instances. Here also, if you have multiple dialog work process and different users logged into the different dialog work processes, here you can see that those dialog work process user also. Then you can do you can also select all user, and then probably anyways, guys. So that is all about AL08 and AL04. Generally, it will not be part of the monitoring sheet, because this is not critical, or this is not very uh, significant thing for the user. It does not poses any danger to your system. So this is generally not part of the monitoring sheet, but yeah, time by time you need to check this. Then let's go to the CPU utilization, ST06. ST06. Okay, here we can see the particulars of the operating system. So generally, we will look for the SAP, we will look for the um, CPU uses. So here you can see the CPU uses is system utilization 0%. So generally, if it is under 50%, 60%, then it is good. But for the production system, we generally uh, prefer to keep this percentage under 30%. But in case it is 50%, then it is fine. So again, each project will have its own benchmark, so you need to follow that. For memory also, if it is under 50-60%, then it is fine. If it is more than that, then there will be a problem. The system might respond little slow. Otherwise, it is fine. Also, here we will notice page in, page out. Okay, this percentage, if the percentage is lower, the more lower it is, the more good it is. Okay, so remember, if the paging is very high, that means you are you are running something which is your RAM cannot accommodate. That's why paging is happening. This is one decode called top. Top also will show you the details about this memory. This is swap space, and we have 251 GB memory, and 198 GB is free, and 94 GB buffer or cache memory. Okay, another thing we see here is disk, no, file system. So here also you can see the file system, and again you need to at least 30-40% file system should be free. Especially there are few mount points which we monitor specifically. One is USR SAP, that should be free enough. SAP MNT should be free enough. This is HANA partition, and as we have database and the application in the same server, that's why we see this HANA partition. And here also we see lots of free spaces. But if your database server is separate, then you will have to look for that also. Here also you will provide client and user start, so you want to see update for all clients, all user. And here probably generally we when we monitor, we generally monitor for last 24 hours. So we are monitoring, let's say we are monitoring at the 8 a.m. So we will monitor from today 8 a.m. Today 8 a.m. and from last day 8 a.m. So last day was 22 January 8 a.m. Sorry. And today can be blank because if we are executing at 8 a.m., 9 a.m., whatever it is, so from yesterday 8 a.m., we are seeing up until today. We don't see any record here, update record. So then it is fine for us. If any update is running or successful, that is also fine. If you see anything failed, then you need to monitor here. You need to mention here that okay, that many update is failed. Okay. Here we see the logs of the system. So again, we want to see logs from the yesterday 8 a.m. and we execute. And these are the logs for last 24 hours. So you will see that there are few things which is only information, and there are few information which is in very high priority. So you can also here you can tick this checkpoint to check only high priority messages. So that is probably which we want. And here we see there are lots of problem. You can double click and you can read more about it. And then based on the error message, you need to take action. And by time, you will also understand which error message we can ignore, which one we cannot ignore. Okay. That comes with the time and experience, but that's how we monitor SM21. If there is any problem, you need to report it here. So let's say we want to report that. How we can report that? So if I double click this, let's say I want to report this error. So I will write down here not okay, and I'll insert a comment, and I'll probably insert it. So that's how we monitor issue. So anybody see he get little bit details. You can put as much detail as you want, but this is how we do it. Again, it varies from project to project. If your project has some other kind of reporting, you need to follow that. But this is most basic one. So this system utilization or system load is basically very um, very crucial topic, okay, because uh, when you will be working in a very demanding landscape or a business where they are very heavily depend on their system, their business operations heavily depend on systems. So that time you will be in lot more pressure to uh, make your system stable and responsive, and performance should be good, so there would be pressure on you. For example, a report runs in a report finishes in 7 seconds, okay, and all of a sudden it started taking 11 seconds. So as a business consultant, you might think, okay, there is only 3-4 seconds. What should be big deal out of it? But they will create a huge mess. They will put pressure on you. They will do the escalation with your manager and everything. Okay, so that's why understanding this system hardware and these benchmarks and these things is very important. Okay, so the point which I'm trying to make is, let's say we have a system, and that system having 30 GB of memory or 50 GB of memory. Okay, and let's make a graph, then I'll able to make you understand correctly. So let's say, okay, no, 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 no. Let's say you have 30 G. This is two system. Okay, this is system one, and this is system two. Okay, and this is your RAM. I mean, the y-axis is your RAM. Okay, y-axis your RAM, and x-axis is your time. X-axis is time. Time. Now you have in both system you have 30 GB of RAM. Okay, you have 30 GB of RAM. So that is probably this slide. You have 30 GB of RAM. This is 30 GB of RAM. So this is your supply, and it is constant over time, right? If in your system one, you have 30 GB of RAM, so throughout the day you have 30 GB of RAM, right? There is no change in the supply. You can't say that in the morning I have 40 GB of RAM in my system, and in the evening I have 60 GB of RAM in my system. In general configuration, you don't have that. Obviously, there is a concept of the elastic computing or elastic cloud. I'm not considering those. In a regular generic system, this is your available RAM, 30 GB of your RAM. Now, you have this system, which is a system one, where the number of user or number of work or number of load in the system throughout the day stays, I mean, quite uh, unchanged. Okay, throughout the day it's fluctuate here. It's like that. So in the morning, it's probably 20 GB, then it reduced to 18 GB, then 22, again 21, again 20, again reduced to 17 GB, reduced to 16, then goes up to in the probably evening where most of the time after lunch, it again crunch up to the 23 GB, 4 GB, but it's quite stable. Okay. Now consider about this system. अरे यार. Now consider about this system. This fluctuates very uh, in very large extent. So for example, it goes to this, and then it peaks like that, and this goes down again at a peak. So in the morning, only 10 GB is being used. Then someone runs a heavy report, it crank up to the 1822 GB. Then the report finishes, it again reduced to 5 GB, 10 GB uses. Then a person comes or two-person runs two reports, and it bullishes to the uh, requirement, bullishes to the even more than the supply. And then all the um, swap memory or the disk memory is started being used, paging go high, your system response is very low. So it might happen when during the morning you are monitoring that okay, my requirement is very, my system health is very good, but is this supply sufficient? No, it is not sufficient, because uh, if this system is very unstable system, and it peaks sometimes out of the supply, sometimes you see 100% memory uses. So this is the graph which I demonstrate here, but in the system you will never see more than 100%, right? So what will happen, it basically touches 100%, then it stays here, and then for the rest of the memory it will start paging. Paging means it start using the swap memory. And then your system, once it hits 80%, more than 80%, so this is the danger zone. This is the danger zone. Once it is crossed, so here you can see it is barely touching the danger zone. But here you can see there are significant amount of time where your system is going beyond danger zone. So these times system will suffer serious problem in performance. But here you can see most of the time system is very highly loaded, but this system is performing very smooth. Why? Because most of the time it is under danger zone, and memory uses does not fluctuate a lot. But this system will show um, less um, good performance. Though in the monitoring, you have reported, okay, this is quite high use of memory and this is quite low use of memory. During the morning, you have monitored this is 8 a.m. in the morning, and let's say this is 8 p.m. in the morning. So during the time, this is fluctuates heavily. So you have understood, right? I want a response from everybody. Can you please unmute and please confirm whether you have understood the concept or not?
Yes, Santosh, understood.
Understood? Anybody has any question on this?
Yes, understood.
Okay, so whenever you are having this problem, like user is complaining about these stuffs, so you don't be in a presumption that okay, in the morning I had a monitoring report saying that my memory use is fine, so you will not look into that. So if there is a problem in performance, you should at least 1 or 2 day you should monitor this waste stuff throughout the day, probably every half an hour, or if um, every 1 hour. There is a option in the system to do that. you can use that, or you can also monitor it manually. Okay. All right. So here we see this is generally does not include in the monitoring as such, but this is very important when you are having any performance issue. Okay. Here few details which we need to keep in mind. First of all, these hit ratio. Okay. Remember, the hit ratio means number of time. So let me open up the notepad. So what is hit ratio?
Are you sharing the screen? I'm not getting it. I'm not sure.
Okay, let me reshare it. Let me reshare it. So hit ratio is number of times our data is requested and number of time data found in cache memory. So this is the formula for the hit ratio. So what database does is, or not only the database, for any high performance system, always there would be a cache memory. Okay, these cache memory will contain the frequent access data. So data which which is being accessed frequently, that part of the data actually stored in the cache. Cache is generally a high performance memory uh, which can be accessed in low time. So for SAP system or database, what it does is generally data is written in the disk, right? But the cache is the area of memory which is located in the RAM, and database system generally stores the part of the data which is very frequently accessed in the RAM or in the cache, you can say. So those data is getting accessed frequently. So in case there is next request comes, instead of going back every time in the database hard disk, it will pull the data from the cache itself. So it is getting pulled from the RAM, which is way faster than accessing the disk, right? So that's the use of cache, and that actually boosts the performance in a very positive way. So let's say you have requested a data 1,000 times. Okay, you have requested 1,000 times a data, not only a particular data, many different data you have requested 1,000 times, and among those 1,000 times you have found those data in the cache 988 times. Okay, so what would be the cache ratio? The cache ratio would be 988 by 1,000. This is the hit ratio, which is equals to 98.8 into 100%. Okay, into 100%. Into 100%. So this is the cache ratio. So the more greater is the cache ratio, that means the more time we have found the data in the cache. That means the system will perform more positive way, more better performance we will get from the system, right? So here what we'll look is the hit ratio should be more than 90 to 95%. In ideal system, what we target is more than 98% hit ratio. If the hit ratio is more than 98%, then your system will perform excellently. Okay. So the hit ratio is basically the number of data found in cache by number of time data is requested. So here you can see that different hit ratios. So if it is below 60, 70 or 80, then what you can do is you can run some database statistics report. I don't remember the report name exactly. I'll tell you tomorrow. I'll just forget the report. So it basically reorganize the database data so that data becomes more organized, and data searching is more efficient, and the cache building also is a part of that. So cache is freshly built so that hit ratio increases and the data is found more easily in the cache. The hit ratio increases and total system performance also increases. Okay. Also, you need to see the table buffer. Table buffer use should be low. Okay. So currently 35% is used. So that is not much significant amount. So that is fine. So table buffer also, there should be free space in the table buffer. If it is not free, then you will see performance degradation. So here also you need to check the table buffer. These are not significant like program CUA. This does not contains a huge memory. So this is not the concern for us. Here also the hit ratio is good. And also heap memory, you see heap memory currently is in use is 0 because we have sufficient RAM. So when you see that RAM is choked up, I showed you in this graph. So in this region, if you go to this ST02, you will see that heap memory is using in a large extent. So you understand that, okay, my RAM is getting choked up. Also, you can verify the fact in the top command or ST06. But again, this is also one point of one place where you need to check. If your RAM is choked up, you need to increase these memories. Okay. We will see how we can increase these memories in profile parameter, but for the time being, just understand that uh, when your RAM is full, then these memories are getting started to use. Okay. So if your RAM is not enough, then you need to probably increase the memory. If it is under certain limit, your RAM is choked up. But if it is under 30%, 40%, then also you are good. But if these also getting filled, then you need to increase your heap memory. Okay, so now I'll write, okay. Then batch job monitoring. So during this um, work process overview in SM50 or SM66, we are talking about the BTC work process, right? Background work process. So those background work process run programs, and those called background jobs. Those basically similar program to other above programs, but those run in the background without any human intervention. So in this section, what we check last 24 hours if there is any background jobs failed or not. So I'll probably check from yesterday 8 a.m. to today's current time. Okay, and I'll check only the cancel job. No. I'll see only the cancel job. So you see, we don't have any cancel job, so that means we are fine. So we can write it as okay. But in sometimes we want to also check if a job running or not, if it is a job active or not. For example, we are running running an activity, and as a part of the activity, there is a job which should run in the system. So if you want to check this, is there any job running or not, then you can select those and see what are the jobs. See, let's see, this job finished and this is released. That means it's ready to be executed. These are finished jobs. So let me uncheck this finished job and execute it. So see, there are lots of job is released which is expected to run in certain point of time. So that is what we monitor. We monitor failed job here. Okay. Now there are plenty other things which we need to know about the jobs, like how we schedule it, what is the other details we require to run the job and all. That we will see in later part when we'll go into the job administration. But for the monitoring perspective, this should be enough that you go to SM37 and click only cancel job, and then select all those things accordingly and execute and see if there is any cancel job or not. If there is any cancel job, then you can monitor it, report it, sorry. Then we'll go to the SP01. In SP01 also we check for the failed spool request, and again we will see from yesterday there is no time selection, that is fine, and we execute. So here also we see the list of the print request from yesterday. We'll see the status. If anything is red and failed, then we need to monitor it. Otherwise, it is fine. So these are the printing requests generated from the system. It can be generated by the jobs, so the automatic generation request. Also, if you want to print yourself any page, so let's say I done LP01 and Control P, and I'm giving a printer name. I don't know whether it is this or not. So now it is spool request is created. Okay. Okay. So you see, this spool request is created by me just a few seconds ago. Okay. So we need to monitor whether any printing request is failed or not. Again, we will run in more detail about printers when we will learn about printer configuration. Goes to ST02. This is one of the important monitoring decode which we need to monitor. So here what we see, whenever we are running any program, for example, we are running so many decode from the morning, right? But those decode does not have any importance or any job for running the program itself. It's just a code for this code for a ABAP program. It's just a short name for the ABAP program. But whenever you are running any T code, basically a ABAP program is running, right? So also whenever you are running background job, ABAP program is running. So whatever you do in SAP system, there is an ABAP program running. So if those ABAP programs runs into a statement which is cannot be executed, maybe a syntax error, maybe a runtime error, maybe any error in the data, then it generates a detailed report of that error, and that error you can find from this ST22 code. So I don't have any error in the yesterday and today. Let's check whether we have any error in last few days. I'll clear all the selection. Yeah. I'll try to print out a dump from another system, and I'll try to show you. But this is very much necessary, because time by time you need to analyze above dumps. But for the time being, just understand that if you have the dumps here in yesterday or today, then you need to monitor it. I'll try to collect some dump for tomorrow's session so that I can explain you how it looks like, and also I'll try to create some screenshots under. Okay. SMQ1, SMQ2, SM. So this is QRFC monitor. QRFC monitor means if you have your system connected to a remote system, okay, and there is a data going from your system to other system, okay, so that data is showed up in this queue. Again, you clear all this queue, and if you have a failed queue, then you have to inform the respective module consultant. For example, if a data going to a system which is for the SD people, so you need to consult to the SD people and say, hey, your queue is failed. Can you please check why it is failed? Okay. Similarly, SMQ2 is for inbound. So in SMQ1, from your system to any external system, data is shown. In SMQ2 inbound, so from external system to your system. If any data is incoming, then it will be shown here, and you will, if there is any failed entry, then you need to investigate. SMQ1 here also you have to write SMQ2. Okay. Then these two transaction codes are very important transaction code, DB12 and DB ST03. So let's go to DB02. In DB02, we manage our database, okay, our database connections and everything. So here, few things we do as a part of the monitoring. Obviously, there are plenty of things to do here, but for monitoring, we do couple of things. First, we check the backup. Okay. We check the backup. So here you can see the backup finished, when the last backup is finished. So if you see anything failed for last 2 days, then you need to report it back. You need to report it back. So here we can see that database happened on 29th of 8, 29. So this is a very old backup. This is not I'm telling you for the example purpose. In productive system, you will see everyday backup is happening. Every day's backup is happening. So you will see those backups information, and if it is failed, then you need to immediately inform your supervisor or the concerned department, or if you have a separate backup team, you have to immediately inform them, because if your backup is not secured, this business data is at risk. Also, you can go to DB12 transaction code, and that is also part of this. So this can be also accessed using DB12 transaction code. Backup overview is DB12. Okay. One more thing is important here is the size information. Go to current status overview. Here you can see the size. Again, for a healthy system, at least 30-40% space should be free. In case of both memory and OS also, CPU also. So here you will see that. Okay. Here you can see that RAM uses. So uh, total allocated limit is 233 and 94 is uses. So used, so it is fine. Also, you need to check the database disk uses. This also needs to be free, at least 30-40% but percent should be free. So this is an important thing in the DB02. So if it is at least 30-40% free, that means you're good. Okay, so these are the two things we generally monitor in the DB02, at least for the monitoring purpose. One is you have enough CPU memory and disk space free for the database operation. Another is your last database backup is completed. So these two aspects of that database administration from monitoring perspective. And lastly, we will go to ST03N. This is a performance overview monitoring tool, or you can call it workload monitor, same thing. So here you can monitor your workload, how your system performed. But it works only if your kernel or OS call is running fine in the OS level. Okay. So what here are few options are there. One is a week basis, another is month, and another is day basis. So the system is installed only uh, 2 days. That's why it is you can see the option for only 2 days. But if your system is like 1-2 years old, then you will see those details here, like month wise details. You see January, December, November, like that. But also these data, there's a huge amount of data, like so many things, like what are the programs running, which user is running, what are the programs um, which is running maximum. So these are a lot of the information, right? And that creates a overhead in the system that eats up lots of data. So there is some housekeeping jobs which will keep cleaning those data. So if you don't run those house cleaning jobs, then you will have the data from the beginning of the time when your system is installed. But in general, we keep a check on this information, because we generally don't need very old information, like what was your RAM uses 1 year ago or 2 year ago. Generally, we don't need that, right? So we generally keep 3 to 6 months of data maximum. I have seen maximum 6 months of data. So there would be a job running which will cleaning any data which is older than 6 months. So here you will see only data which is uh, 6 months or less old. Okay. So let's say we want to select this week. So we select this week, and we go to this transaction profile and standard, select task type dialog. So here you can see that the reports which we ran, and what is the number of time it ran, okay, and how much time would it take. So these information in general at the first glance, it will not sound, or it will not sense much to you. When it will sense is when there is a problem, or you start benchmarking that, and you keep a track or note of that. So in that time, it will be more meaningful to you. So you see that especially when you go to the workload overview and go to the dialog. So here you can see that the dialog response time is 449 seconds. So there is a Excel sheet which we prepare generally. Each project will have it called some called system health report, uh, and there are different names in different projects, but in general it is system health report. So those will have a historic graph. Okay, for example, those reports will have historic graph, and that will show you how your system performance changed over time. Okay, so this will probably have a graph like that, and you plot your dialog response time every month. So probably first month it used to be 400 something, 400 something. Next month it is went up to 600. Again it came back to 400. Again it shoot up to 700, and then 800. So this what this data tells you is how your dialog response time changed over time. So you can assume a lot of things, or you can get a lot of information from this. One thing could be your user base changed. You have lots of hire in this period of time, so your number of user increased. Okay, then one thing could be you have added new functionalities over here. Let's say you have added yeah, 2 to 10 reports, which will calculate lots of things and do lots of stuff. Though the reports does not, if it is a dialog report, obviously it will have an effect. But if it is something running in the background, obviously it will not affect on at least the dialog response time. But if it is users are running on the foreground on their GUI, and they are getting output immediately, so that will have effect. But if there is no change in the system and you see your dialog response time is increasing, so you will understand that there is some problem in my system, and probably I have to do some cleanups. I have to do some old thing clear. For example, I have told you that these data are getting clogged up in the system, right? So that can be a overhead. There are few other things. For example, uh, uh, there are some tables like softcon or something where uh, when user sends any mails or any attachment, those data will store in the system. So those tables generally tends to grow in very large number, like 200 GB, 500 GB. Okay, just give me a guys, I'm getting a call. All right, guys. So those tables will store those information like attachment, mail attachment, and something. So if your database growth is like quite high, then the performance degradation will happen over time. So you need to time by time, you need to plan to clear those data, or you need to reorganize your database. So there are lots of points or lots of factors which can have effect in your system. So how you understand, if you keep a track of your dialog response time or other aspect of the system, then you can understand over time how your system behavior got changed. So yeah, so that is all about the SE0CN, where you get information about your system altogether. Um, Especially, you need to report the dialog response time. You should be concerned about dialog response time, because if your user is running a background job, if it is take 5 minutes more or 10 minutes more, generally they will not raise a concern. But the moment a report or T code start taking 1-2 seconds more, then they will start complaining about it. Okay, so the dialogue response time is very crucial. And also, as I was telling you, you can check the details about your by the time slice. Okay, here you can see different time slices, and there are other things which you can explore, but generally what we check here is one is transaction profile, what are the dialogue transaction executed in system, and what is the response time. Sometime you will need to sort this in ascending order or descending order, and then you will report top 10 transaction which is took lots of time, and then the dialogue response time of the overall system. So that is the major two thing which we'll check here, and that will tell us about the system load. And obviously each project or each system, I must say, each system will have a benchmark. Okay, so overall the time, if you if you keep a track of your response time, then after certain time probably you will create a benchmark. Okay, under this dialogue response time my system is working fine, and nobody is complaining. And if it is shoots up beyond this, then I start getting complaints, and then I'll need to check what wrong with my system. Okay. All right, guys. So that is all about the monitoring systems. There are few things which we monitor in the OS level. I'll check. I'll show you tomorrow about that. But for the time being, this is all about the monitoring.
Alright, let's test your knowledge. Here is a question for you. Which of the following is not a typical responsibility of the SAP Basis team in an SAP HANA environment? Option A, configuring the operating system. Option B, implementing high availability and disaster recovery. Option C, administering the SAP HANA database. Option D, developing custom SAP UI5 applications. Take a moment to think, and when you are ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comments section. Hey there, want to level up your skills in managing supplies? Our SAP Basis HANA course is here for you. Take it at your own pace on our platform. In this course, you will dive deep into SAP Basis HANA, a powerful tool for handling supply management. It's like a toolbox for planning things, ensuring we have enough products and getting them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors are pros with tons of experience. They are here to guide you and tackle any questions you may have. And guess what? Our students love this course. Folks just like you have found it incredibly helpful. What's even better, it's affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA whiz? Sign up on our page now. For more info, head over to ZaranTech's website.
So again, monitoring is activity which we do every day before business starts, at least 1 to 2 hours prior, so that we can understand whether there is a problem in the system, or if there is any problem happened in last 24 hours, or we also try to identify or understand whether there is any chance of a problem occurring in next few hours. Okay, so we try to understand in advance. That's why we do the monitoring, and monitoring is a job which you have to finish in certain amount of time. So that's why you might notice that in every transaction, instead of doing very deep level of analysis, I tried to give you a benchmark, or I tried to give you a quick reference point so that you can understand the T-code output, whether it is fine or not, because you will have to finish this entire thing very quickly. You need to do 10 different T-codes. You need to go to the OS level, see few things. Okay, so these are the list of things which you need to done. But you have to do it very quickly. You will not have like two hours time in your hand. Probably you will need to finish this in half an hour. That too, you need to finish 5 to 10 production server in half an hour. So if you want to do thorough analysis, it is not possible. So that's why you need to have these benchmarks, so that in fraction of second, once the screen is up on in front of you, you can at a single glance you can understand, okay, this is good. I will um, travel to next screen. So how it happens in real time, I'll show you right now. So let's say I'm doing the monitoring. I'm in front of the screen at 9 a.m. My business starts at 10 a.m. I need to finish this by half an hour. I need to I need to monitor 5 different production systems. So I'll do like this. So I'll go to ST22. Sorry, my screen is freezed. I'll go to ST22. I'll see there is no dump, fine. Then I'll go to ST03N. I'll quickly expand for the last day and then see my dialog response time. I see 134, that is fine. Then I go to SMQ1. I'll clear that and execute. Okay, I'll go to SMQ2. I clear that and execute. I'll go to DB12. I'll see there is no backup failure. Good. I'll go to other transaction code. Let's say SM21. I'll put it as 23. You see there is no critical error. Fine. Okay, so this is the way you need to do in real life. So I just wanted to give you the little idea about how it's done in the real life. Okay, so that's the speed you need to achieve. So that's why you don't have that luxury to go through each and every details of the screen minutely. So that's why it's very important that you set a benchmark, so that you don't need to calculate, you don't need to juggle around many information. Understood what I'm trying to say? So SM50, in SM50, we monitor the work processes. And in SM50, we see the work processes available in the system. Here, 33 work processes available. Among those 33, dialog is 20. And 20 among 20 dialog work process, 19 is free, so which is very good. And update work process, one update work process, that is free. Background 10 out of 10 is free. Spool 1 is free, and update task 2 also free. So if these work processes, which is only one is available, this is busy. So it's fine because it has only one number, so it's expected to busy. So that is not a problem. But if some process keeps it busy for a long time, like 1-2 hours continuously, then probably you will look for it. What is the problem? Who is running for a long time? And dialogue and background, there should be at least one background free, that there should be at least 2 to 3 dialogue process free in order to your system to function. If it is not uh, free at all, then your system will halt or system will be not responsive. But in ideal scenario, what we target is at least 50% resource or dialog and background work process to be free. Here we see all the dialog instances present in our system. If it is active and green, we have nothing to worry about. All good. SM6. In this T code again, we can see the work process, but this time we will see work process for the all dialog instance. In SM50, we were seeing the dialog work process for only the instance which we logged in. How we can understand? Let's go to here. Here you can see that. So if you want to see individually, then you go to SM50. Sorry, SM51, and from here you double click. Okay, if you have multiple work process, you just double click. What is happening here? You double click and it will lead to the work process for that particular instance. So if you have five different dialog instance, you simply double click from the SM51 and then it will show. But generally we use SM66 for the distributed systems, so that we see the okay, it's looking good. Well, here we see the locks existing in the system. This is basically NQ administration. We clear all the things and we execute. We see there is no lock, and this is fine. Having no lock is good. And if there are locks, that is also fine. But if the lock is more than 24 years old, then we need to update the respective user. And if they say that, oh, I don't know about anything about this lock, or I'm not working anymore, you can delete the lock. Then with proper written approval, you may delete the lock, or you may choose to leave the lock. That is also not a problem, so that in next system restart the lock is automatically cleared. Okay. um, mm, mm. So if the lock is not disturbing you, then I would probably say don't bother about it. Okay. We don't know in what data inconsistency it will create if you delete the lock. So if someone complaining that I cannot edit this, and you see that is locked by any orphan NQ lock, then you take a proper approval and delete it. Otherwise, probably you'll wait for the next system restart to clear it. AL08. In AL08, we see the system-wide list of the logged in user for all the application server instances. And in SM04, we see the list of the user which we log in. Again, we can select the user and kick the user out of the system from here. In the AL08 also, I remember that we used to have an option, but I tried to find it yesterday. I could not find it. I don't know what happened. Am I in the AL08 or in the SM04? I don't see any. I don't know. Okay, then ST06, SM13, ST06. Here we see the details of the CPU, RAM, and the disk. And this is the CPU utilization, which is good. Under 30% is very good. Under 50% is good. More than 50% is little bit worrying. And when it goes beyond 70%, if it's a production system, then you have to very carefully observe the CPU spikes. Okay, I have taught you about the spikes yesterday, right? Using that graph, how memory spikes and how CPU spikes utilization. So that is the very important concept. And if you can create a graph like that for you take data for each half an hour, or if each 1 hour, and plot in a graph, then you will probably have a very good idea that how your system is being utilized throughout the day. And depending upon that graph, you can choose your memory or CPU amount, or how much RAM you need, how much CPU you need. You can have a very pretty clear idea about that using that graph. Okay. Here we can see that physical memory is 251 and free memory percent is only 77%. So that is not good. That has to be reported. And swap memory is almost free. Swap size, so it's almost free. That is good. And then we have the file system. In file system also, if any mount point goes below 80%, 70%, you have to worry about. Especially these user SAP MLT, HANA, and the root partition. Root partition is very important. This is the root partition. Sorry, this is the root partition. This is very important. So you should not let the system use more than 70% or 60%. For other mount points, if you keep 20% free, that is fine. But for this system, if it is a production system, I would suggest that at least 30 to 40% space should be free, because you don't know when a large amount of data generates in the system, and or sometimes you forget to monitor it. That is also happens in real life. So to accommodate those human errors, at least 30-40% should be there. And then SM13. Here we see we look for the failed updates. If you have any failed update, then you need to report it. SM21 already show. This is 02. Here you can see the basically hit ratio and swap space utilization. We go from the bottom. So if the hit ratio the more is in the hit ratio percentage, the more your system is performing good. Okay. Well, generally this screen is used to assess the system performance degradation issue. So if your system performance is degraded and you see your hit ratio is coming down, so you perform a database reorganization activity, which is basically a command in the OS level, a SQL command, which is basically reorganize your data in your database or database storage or hard disk, so that you get a better performance. Okay. Also, you see the how much hit ratio of the page area, extended memory. These are also important. Here also you will see that how much table buffer is used. Okay, there should be a good amount of table buffer free. Here table buffer is 1.9 GB and 1.1 GB is free. So this is good. SM37 SP01. In SM37 we see failed jobs. If there is any job failed, we inform to the respective user. So what we do, we select cancel. Okay, one thing guys, you have to mention the time. Okay, otherwise what will happen, you will mistakenly report the same thing twice. We generally monitor like this. So yesterday 8 a.m. to today 8 a.m. So in between this time only we report. Anything beyond that we will not report, because if we don't include the timing, what will happen? Let's say we monitoring here at 9 a.m. and we remove this thing. Okay, so if any error happens at the 8:45, then this will be reported again. Yesterday, sorry, again tomorrow when we'll do monitoring now. If we give the yesterday days, the same thing will be picked up again. So tomorrow also you will report that. So that will create a problem, right? So that's why we stick to a specific time slice, and you have to use it every day so that anything which happened and reported does not get reported back twice. So there is no failed job, so no problem. ST22. Okay, so this is for school administration. Again, you create. You want to see for all users, and you want to see from yesterday, and all client. And if there is any failed status, print request with failed status, you need to report it. Okay. SMQ1, this is for outbound queue. Execute. If anything failed in the outbound queue, you report it. And then SMQ2. Again, this is for inbound queue, the data coming from the remote system to our system. So nothing is selected, so we are good. DB02 STC. DB02. In the DB02, we see the backup status. Also, we can access the same thing using DB12, same T code. I mean, it produces the same output. And if you go to the current status overview, you see the database related parameters like CPU, memory, and disk usage also. So if all those looks good, then it is fine. I mean, memory is under the allocated limit, your CPU is good, and your data volume is also good, then that's fine. Okay, last code is ST03. I already shown you in the ST03N, you input specific time, or you can input week, month as per based on your requirement. Here we generally few details we look for. One is the dialog response time. In the workload overview, you select the dialog response time. You see this time. So that is the number we're looking for. And if you plot a graph of this by taking value for each week or each month, so you will see that how your dialog response time is performing. So that way you can understand that, okay, I have a system got down performance downgradation or upgradation. Here also you can select the task type dialog, and then you you sort with this one, and so that you get the list of the transaction code which is using your top dialog response time. Okay, so that was about the all right. In the meantime, let us continue this topic. So when we talk about the SAP start and stop, okay, we have to follow some rules. Okay, so when I was talking about is SAP architecture. So what we discussed is the three layers of the SAP system. Okay, one is presentation. There is application, and then there TV. Okay, so this presentation layer does, for at least for this topic, it does not hold any value, because we are now stopping the SAP system. So it's all about the SAP system itself, not about the presentation. We don't care whether a user is working using his SAP GUI or SAP web browser. If anybody is working on any particular thing, and if the system is shut down, so there might be some data loss. So that's why we always prefer to check SM04 L08 before you shutting down the production system at least. But you can do that. Like there is nothing holding you back doing this. If a user, no matter what are the things they are working on, if you want to shut down your system, there is nothing stopping you. Okay, so at least we can say, okay, this is not good that you shut down you with active user, but this is not any constraint for SAP shutdown and start. This is not any there is no any formal issue which is holding you back. So we can remove this thing out of the picture for the SAP start and stop activity. Okay, now application server is basically two things, right? One is ASCS or central instance, another is dialog instance, correct? So we broken down this application server into two parts, ASCS and dialog instance. So remember one thing, what I told you in the architecture part, ASCS is the brain or master of the SAP system. It's the mastermind of the SAP system. So when we start any SAP system, first ASCS has to be started. The message server especially has to be started because it's basically do all the intercommunication. So it must have the status of the dialog instance, whether it is up or not, how many dialog instances you have, and among those dialog instances, how many is up, how many is down. So so as it is acting as a communicator or the middleman, or the or it is having a bird eye view of the entire SAP system, so it has to be started first and then the dialog instance. Okay. So there is a specific sequence which we need to follow if we want to start and stop the SAP system. So for start of the SAP system, first we start the database. Okay. Then we start the ASCS, and then we start the dialog instances. So if there is multiple dialog instance, first we start the primary dialog instance. Primary, which primary dialog instance, what I'm trying to say here is we generally start the dialog instance which is installed in the primary application server. So better I write this way, app server, and then dialog instance of the additional application server. Additional application server, or we can sometime we call it ASS. Okay. Sorry, AAS, additional application server, and this one we call it PAS, primary application server. what should be the stop sequence then? First we first we stop the all additional application server. Then we stop the dialog instance of the primary application server. Then we stop the ACS, and then we stop the DB. Okay, so that is what the start sequence and stop sequence. Being you, if you want to take a note, you can do that, or if you understood correctly, then you don't need to take a note. So there are few things which you need to understand so that you have the better understanding. Okay. So during the architecture lecture, I have told you that ACS does not have any dependency on DB. So if DB is down, so ACS can be started. There is no dependency. So that means this ACS can be started before the DB, no problem. So why we put this after the DB? Because in general, when we use the command in SAP, generally we command a single, we fire a single command, start SAP, stop SAP. So if we do that, it will automatically follow the sequence. It knows which are the dialog instance, which are the central instance. So once we fire start SAP, then first it start the central instance, then starts the dialog instance. So if your DB is not up, then this will fail. So we don't want that, right? So that's why we start this one first. But if you want to stop manually one by one, then you can start the ACS first, then the DB, then the dialog, no problem. Similar goes for the similar goes for the this also, stop also. But it is always suggested that you start the DB first, then central instance, then the dialog instance. Okay. So let's do this right now and see. Okay. So for that we need to switch to the SID-ADM user. So there are few users which the standard user created automatically or created as a prerequisite of the SAP system installation. Standard user. So here you can see that there is two standard user. One is SID-ADM and another is SAP ADM. So these are the two standard user. So as we have three systems installed in this system, one is A4H. So there is a user called A4H. Another system is installed MJ1. So there is a MJ1 ADM. Another system is installed H4A. So there is a H4A ADM. And SAP ADM is common for the all three systems. So there is two standard user as per the system which is SID-ADM. We call it SID-ADM user. SID-ADM. We write it this way. So if my system name is A4H, so user would be A4H ADM. And then there is SAP ADM. And in the case of Windows system, there is a user called SAP Service SID. SAP Service SID. So if my SID is A4H, so what would be the username? SAP Service A4H. So this should be my username in Windows. You can go to the task manager if you are working on the Windows system. Go to the services. No. Hi. Actually, can you please ask Monoranjan to provide the administrative access in the RDP server I'm not able to show a few things to the student. Okay, I'll ping in the group, yes. So what we are talking about, these are the standard user of the SAP system. One is SID ADM, another is SAP ADM. If you have a Windows system, then you will have the SAP service SID. Okay, so let's see this start stop activity. So if we see this architecture of this system, the training system which we are working on, we will see that this is a 2-tier architecture, okay, not 3-tier. So the meaning is the application and DB is installed in this system, in the same system. So if we go to USR SAP and we see these system we are working on currently F4H, and the H4A, this is the HANA system or HANA DB SID. Okay, so previously for other databases like MS SQL, DB2, Sybase, Oracle, for that you don't see a SID folder for database in USR SAP. But for HANA system, uh, in whatever server you install, whether it's in a separate server or in the same server of the SAP system, you always see there is a SID for the HANA database. Okay, previously for other database you won't see that, but for the only for the HANA database you see along with the SAP system ID there is a HANA DB SID also, and that is also present in the user SAP system. So these are the SID for the HANA DB which currently we are working on, and this is the SAP system. Okay, so right now we have two administrative users to administrate this SAP system. For this A4H, we have the A4H ADM, and for this H4A, we have H4A ADM. H4A ADM. So these are the standard user, and we will use that standard user to stop the SAP system. So right now our SAP system is running. So we need to stop the SAP system. So in order to stop the SAP system, first step is you stop any additional dialog instance, right? But we don't have any additional dialog instance. We have only one primary server. So which server is called primary application server? In which server the central instance is installed, that is called primary application server. Okay, but in some cases if you are using a distributed system, it can happen that your central instance and your dialog instance are not installed in the same server. It is completely in the different server. So in that case, during the installation, uh, which dialog instance is installed first, that will uh, call that will be called as primary application server. But in practical scenario, there is no difference between a additional application server and primary application server in terms of usability. Okay, so you can stop any uh, additional server, uh, doesn't matter. But in theory, we just want to follow this approach. So right now I want to stop this application server. So this application server belongs to SAP system, right? Not for the DB. So our SAP system ID is A4H. So I will switch to the A4H ADM. So once I switch to the A4H ADM, then I will stop the A4H this application dialog instance first. But before I install, before I stop this dialog instance, in some version of the SAP system, there is there is a command available which is start SAP, stop SAP. So if you fire that command, it will automatically stop all the dialog instance first, then the central instance, then the DB automatically. So let's see if that is available here or not. If not available, you will need to stop manually. Okay. So so let's fire that. And before that, let us see the status of the each instance individually. So for that, we need to fire that command SAP control. Take a note of this command -nr. nr stands for the instance number. So let's check instance 00, then function, and then get process list. If you fire this command, you will see that instance 00 is basically belongs to the HANA database. These are the HANA database processes. When I will teach about the DB specifically, then we will go in detail about these processes, what are these processes, what it does. But for the time being, just understand that a 00 instance belongs to the HANA database, and there are processes running for this HANA database. So again, if we check 01, we'll see this is the dialog instance, because we see this plus work process, and that is belongs to the dialog instance. And then 02 is the central instance, because Mrs. Server and Q server is there. So we have all three servers, all three instance, database instance, dialog instance, central instance, all running in green condition. Okay. Now let's fire the stop SAP command. Okay, so there is no stop SAP command here, but in some version, some kernel, you will find this stop SAP command. If it is not available, then we will shut down using the same command we used. So first we will shut down the central instance, dialog instance, which is 01. So it gives you prompt back immediately that stop command is successful. Now it takes some time to stop, which you can monitor using this. So first, see, I'm kicked out of the system, and I got the message here. IG is getting down, and now dispatcher, everything is down. Stop. Okay. So my dialog instance is now stopped. Now I'll have to stop the ACS. This is successful. So you see, it is stopped. Okay. Now I'll have to stop the HANA database. So you can stop the HANA database in the same manner. You just fire this stop command using instance 00, but there is a better way. I'll just show you that. So I'll exit from this A4HADM, and now I switch to H4ADM, which is the SID for the HANA database, administrative user for the HANA database. And now I'll fire the command HTTP stop. So now it will shut down the HTTP HANA database. It will take some time, but eventually it will stop. Okay, now the system is stopped. You can verify using this. You can verify using this command HDB info. So system running, you would see lots of process running. So all those process, like when you see executed that command, let's switch back to A4HADM and go for the 00. And here you see, yeah. So here you see that we don't have those processes running. So last time when we run it, you have seen that there are a list of processes running for the instance 00, which is HANA database. Okay. So now we will start the system once again, and for that we need to start the DB first. Again, we will switch back to H4ADM because that is the user for the HANA database, and we'll fire command HDB start. Keep a note of this command: HDB start, HDB stop, and HDB info. I think guys who has experience like 1 or 2 years, you were saying they have already this experience of starting stopping, but for others probably this is new. So I would request each of you to practice this. You have the server with you entire day. Anytime you find some time, you can practice it. What is the next topic we should see? This is done, almost done in 5 minutes. Let's go for this user authorization and security. I'm choosing the easy topics first so that you don't have to, go through very tough things, and we gradually enter into this little complex topics. With overview Windows and Unix. It should be done way before these topics. Anyways, this is also done. ST03N. Okay, HANADB is started. If you see HDB info, you should see all the processes running. Last time we did not see this, right? These processes. So now we are good to go to start the central instance, then the dialog instance. So we don't need this prompt anymore. Now we'll switch to the SIDM A4 HADM. A4 HADM. And now we can start the central instance first. So let's check. NQ server, message server, both is down. So we will start this. And we'll see this is yellow, that means starting. And both is now running. And dispatcher is yellow. Now the dispatcher is green, gateway also green. So all the processes running in the central instance, and we are good to go for the dialog instance or primary application server instance, whatever you call it. You'll see both the processes down. So we'll start it now. It is started. Let's monitor it. Dispatcher is yellow. Gateway is scheduled to start after this dispatcher start. It is basically waiting for this dispatcher to start once it is started. And so guys, if the database is down, if you try to start it, then after dispatcher is getting yellow state, server state of starting, then immediately it will fail and it will become gray. So now all the process is started and we should be able to access the system. If we go to the logon, and it should be accessible. Yeah. So first time it takes some time, and then once the cache and everything is built, then it will immediately open. So that is all about the start and stop. So guys, I would request if you have any question. So I wanted to start this topic for the Unix and Linux so that you can have the understanding of what I'm talking about. Or in future also we will see different topics, or we will do few things in the OS level. So let's understand that first, so that we don't have problem doing that. So OS overview is not only the Windows and Linux. There are different flavors of Unix available in the market. We have SUSE, we have Red Hat Linux, we have generic Linux x64-bit. So all those platforms are available for the SAP system, as well as Windows is also available for the SAP system, and there are different flavors of Linux. Okay, now for the HANA system, especially only Red Hat Linux and SUSE Linux are available. For other Linux or Windows are not available for the at least HANA database. You can install your application or SAP S/4HANA system in Windows or any other system, but your HANA database must be installed in your Unix system, which is either Red Hat or it is what you can do is few things you need to do. One thing also you need to do is check your system information. Here you can see how many processors are there. That is important for you. How many. So I was talking about some fundamentals of the Windows system or Linux system, which is needed for the SAP Basis consultant. So you need to know your uh, you need to know the operating system version, and also the CPU, what kind of CPU is installed, and how many CPUs are available. What is the system type? Is it 64-bit or 32-bit? These informations are important, especially when you are doing any maintenance stuff. So, for example, you need to install a piece of software. So, softwares are compiled targeting the CPU versions and the system type. So if you bring a 32-bit version and install in a 64-bit version, it will not work. So that's why you need this information time by time. Okay. Also, if you are administrating the Windows system, this is a very important thing. So this is called services. Here you will find all the SAP system services and the database related services in Windows system. Okay, so I don't have SAP installed in my desktop, so I'm not able to show you, but uh, if you are administrating a Windows system where SAP is installed, you will see that some services which starts with SAP something. Okay, so the name probably SAP underscore um, system ID A4H underscore 00, something like that. You will find a service like that here. So for each instance, there would be exactly one services in the services.msc in Windows. In Unix, we don't have anything like that, but obviously there are processes which runs at the OS level. But in Windows, um, you can have that services or see the services in the services.msc. Also, one thing to notice here, that you will have SAP MMC, a piece of software. If you don't know, I have here or not. Okay, once I got the administrative access, I'll show you that piece of software in here. But for the time being, there is one services each and every instance, and those services needs to be started first if you want to start your recipe. Okay, so without you start your background services, you cannot start your service in the SAP system. Okay, your instance cannot be started until unless you started your background services. One more important thing here is the task manager. So here, you can see the running processes. So you will see running processes for your SAP system. Okay. So that is also one thing which you need to use time by time. Sometimes you need to uh, kill a process. For example, you are not able to kill any program. You have run a tool in the OS level and that is not closing. You are clicking the cross button, but it's nothing happening. So in that case, you come here and right click and click on end task. So that task is ended. Okay. This is not a server version. So this is very different. Okay, here it is. So this is the advanced system settings. You can right click on this Windows. Sorry, where it is. You can just right click here, go to properties and uh, click advanced Windows settings. And here a few things you need to check. First of all, computer name. So this is the computer name here. Okay, so that is the host name of your computer. So you might need to change your host name. If you want to change your host name, so you go here and you change here. Okay, so that is one thing you need to perform. Another thing is you go to the performance and go to advanced, and here you need to change the virtual memory. So virtual memory is nothing but the swap memory. So swap memory is a part of the hard disk or uh, disk space which is allocated for system performance. So you have your primary memory or RAM, right? But in some cases, it happens that RAM is exhausted. So at that time, system will use this memory to use it as a RAM. So few part of the RAM will be data of the RAM would be shifted to this memory, and when it is required again, it will be pulled back to the memory. So it will be basically used as a uh, extension of the RAM or few extra memory for the RAM, and that is very much critical for the SAP system. We set huge amount of memory for this purpose. In some cases, we assign 50-60 GB memory so that there is no memory crunch when the spike happens. Okay, so all you do is uncheck this button, and for the D drive, let me set up see the custom size. Let's do the initial size 20 GB and maximum 40 GB. So at the beginning it will occupy 20 GB and it can grow up until 40 GB, and then you click set. Okay. Right. So this is one one thing which you need to do at the beginning of the system setup, or if you see that your memory usage is very high, you want a you want a action which can assist your system to avoid any performance issue. Well, there would be performance degradation, because anything which offloads of the RAM, it increases the response time, and the system becomes little slow, but at least you are not in the deadlock situation. Okay. Okay, so this is a little tour about the Windows system. And for the Linux system, you can call a command called uname-a. Keep a note of this. Here you can see the Linux system and the host name and the version of it. Okay, this is also information for you, important for you. Then there is a command called top. Here you can see that free memory and CPU details also, and the running processes with the port also. Okay, so this is also information important. One more information is you can use this command to check your memory and swap memory also. Okay. Also, you can check your process list. If you type ps-ef, you can see the entire process list. But if you want to filter the list, all you do is, after this ef, type a pipe. Space is not required. I'm just putting the space to uh, uh, to the purpose that you can read it better. Okay. Then there is a command called grep, and then the word you want to search for. So let's say I want to see all processes which have this SAP word in it. Okay, so I'll write the command ps-ef grep SAP. Now I'll be shown only the processes which has this word in common. So these are the processes which has this SAP word. All right. So that is little overview of the operating system. There are other things also, but I will teach those things when it comes. Okay, I mean there are times when you will encounter these topics during learning other topics. For example, we are doing patching, or we are doing installation. Then these topics again come, and then I will describe those in detail. So these are the basic administration, like process administration, especially, that is used very much. For example, I have shown you how to end the process in the Windows system, right, from the task manager. In the Linux system, what we do, we use a command called kill, and kill has a priority 0 to 9. So generally we use the highest priority to kill it, so that any other any other process cannot override this priority. So you can put 1 to 9, but we use generally 9. Then the process ID. So this is the process ID. So if you enter this, and now if I hit enter, it will be process will be terminated. So I'll not do this, because this will abruptly close this process. So yeah, so this is the way we kill a process. And also, if you want to kill multiple processes at the same time, you can use this way. Okay, so you put a space and how many process you want to kill, you can do like this way. Okay, and for example, you have entered a command which you don't want to execute. So what you will do, you will simply type Control C. If you type Control C, then the command will not execute. It will simply abort that line, and it will prompt will come to the next line. So that is one information. Okay, all right. Then I'll teach you a little bit about using the command line tool so that you can edit the files. Okay. Um, okay. So you already know how to travel through directory. Like you use cd space path and then cd dot dot everything. Okay. So one more information is if you type only cd, it will uh, lead you to the home directory of your user which is using currently. So if I type pwd, which is present working directory, I am a root user, right? Like so if I type the command who am I, it will give me the user I am currently using to access this system. So I am root user. Okay. So and this is my home directory. So let me create a file over here. So touch test.txt. So I'm just creating this file here, and if I type ls, I'll see that this file has been created. Okay. Now I want to edit this file. So how I can do it? So there is a command called vi. Okay, or I'll type this vi and then test.txt. Now I'll enter into this file. So now I can type anything which I want, and I can save it. So how I can save it? First, I have to press escape. So there is a escape button at your right top corner of your keyboard. So first I type escape, then I type colon, and then I type WQ, and that's it. So to save the file, what I do, first I press escape button, then colon, then WQ. So this is the way to save it. But if you don't want to save it, you have done some changes in the file, but you don't want to change it. So what you do, you type escape, then colon, then Q not. Okay. So you override the changes. So now if I type this text file. Okay. I use cat. Here you see that I have saved these things and it is saved. Okay. Now I'll do once again, and I'll type once again no file name under the cursor. Okay. So if you are not able to type, what you need to do is you need to type insert. Okay, you have the insert button on your top right corner of your keyboard. You type insert. Once you type insert, then you will be able to do these changes. Okay, this is a new change. I write this. Okay, now I don't want to save it. So what I do, I type escape colon q not. Now if I type this once again, you see there is no change has been done. So there are times when you need to use these commands to do the changes in your file which is stored at the OS level. For example, profile parameter you need to change. So you will use these commands. You use vi command to open the file in the text editor, and then you type all files. If you are not able to type, you type the insert key. Once you have done type, then you type colon escape WQ, so the file is saved. Okay. All right. So that is about the little file modification. What else? What else? Okay, I'll show you a few more concepts here on the operating system. Let's say let me change the user to A4HADM. A4HADM, and I want to go to the home directory. So if I type the command pwd, which will show me the current working directory of the prompt. Okay. Now let me list the file here. So here only one file is there, trans.log. Let me create few more files. Touch file 1, touch file 2, and let me create a directory mkdir dir1, mkdir dir2. Okay. So I created few files here. I'll use ls-l to long listing of this folder. So it will show you whatever the file folders present in this directory. So right now I'm in the A4HADM directory. Okay. So in the folder, you will see that multiple files and folder are there. So how we'll understand which is file, which is folder? First of all, the folder will be in the different color. If not, then you will see this D means directory. Okay, so that is one significance of the directory. Okay, and then now we will learn little about changing the permission. Okay, so the way permission is written here is this lines. Okay, so let me show you in little bit details.
All right, let's test your knowledge. Here is a question for you. What is the purpose of the SAP HANA cockpit? Option A, monitoring and managing the HANA database. Option B, administering SAP system landscapes. Option C, developing custom HANA applications. Option D, all of the above. Take a moment to think, and when you are ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section.
Okay, so in Windows, how we give the permission? Let's say I have to set permission of this file, this folder. So we right click and click on properties, go to the security, and click on edit. Now you select one user and click on allow or deny. Okay, if you want to add a user, also you can do that from here. So these are the users available here. These are the users available here. So if I want to set a permission for this user, then what I do, I'll simply click OK. Now it is here. And now I can just edit the access, whatever access I want to. Full control or read and execute or read only, modify only. I can give the permission accordingly. Then I click apply and it is applied. So it's kind of nice GUI thing for the Windows. Similarly for the files also, you go to properties, you go to security and you edit it. And if it is if you want to change permission for user which is already there in the list, you simply select the user and change the permission. But if your user is not available here, you can just add from here. You click on advanced, find now, then all users would be in this list. You select any user, click OK, and now the user is available and you can set the permission. So that is very straightforward. But in the Linux, it is little bit complex, but it is interesting too. So how it is works in the Linux, I'll show you. So in the Linux, there is two concepts for the owner and the group. Okay, so this folder, the owner of this folder is A4HADM, and this group is this group has uh, permission also for this folder. Okay, so every folder or file will have assigned one owner and one group. Okay, so access details for this group and owners is written here. Okay, so let me copy this thing in the notepad. So in this RWX, actually we can segregate into three parts. So this first part is for the owner. This second part is for the group, and this part for the rest of the world. Okay, so and here this R means read and W means write and X means execute. Okay, now if you see closely, I told you that these three for the owner, these three for the group, and these three for the rest of the user. I mean, whoever accessing except owner and the group, these three for the rest of the users or rest of the people. So this signifies that the owner has read, write, and execute permission on this folder. And this means the group, whoever having inside this group has read permission and execute permission. They cannot write it here. Anything, they cannot write anything here. And for other people also, there is the read permission and the execute permission. Okay. Understood? Guys, hello. Can you please confirm?
Yes.
Yes,
So
Santosh.
I believe that there are people who will automatically understand this because they have already worked. But other than them, if you are not able to understand, please raise immediately, because I will go through flow, and if you are left behind, it will be problematic for you. Okay, please raise your voice. Don't hesitate. So again, this is for the owner, this is for the group, and this is for the public. Okay, so if you now follow this concept, you can see that here for this trans.log, this is for the owner, right? First 3 digit for the owners. So by seeing this permission, we can understand that A4HADM can read and write this file. It cannot execute. Okay, and that is because this file is a simple log file. There is nothing to execute, so it's not relevant also. But we can say that A4HADM user can read and write, but it cannot execute. And people who are part of this SAPSys group, they will have this permission. So they can only read, they cannot write, they cannot execute. And for the other people, rest of the world, I mean, the users which is coming from the internet, coming from the network, or the users which are present in this system but not a part of the SAPSys group or not the A4HADM, those users will have only read permission. Okay, so that's how we interpret this permission. For any file, if you talk about this file, so again, the owner is F4HADM, so owner has this permission, so he can read write, and then the group is SAPSys can only read, and this is for the rest of the user. That's how we interpret the permission. Okay. Now, obviously, time by time we need to change this permission. For Windows, we have already seen how we can change in the Windows. Now we will learn how we can change in the Linux. So to change the permission in the Linux, we follow a numerical format. How numerical format works is there are number assigned for the each of the permission. Okay, so for read the numerical assigned is 4. For the write it is 2, and for the execute it is 1. That is the number assigned for the each type of permission. Okay, so if I consider this permission, which is this one, what would be the numerical form of this permission? The numerical form would be first this three letter RWX. So we have R, we have W, we have X. So if we add this thing, so for R it will be 4, for W it will be +2, which is 6, and then X +1, which is 7. So for RWX, the numerical format or the numerical equivalent of the RWX is 7. Okay, and then for this RX, so now we are seeing a format where W is not available. So W is not available. So in that case, what will happen? For R, we will take 4. For X, we will take 1. So numerical equivalent of the RX is 5. And again, we have RX. So here also we will have 5. So that's how we interpret the permission in the numeric form. So there is no space in the system. I just segregated it. So if I remove the space, this would be the permission. So this is the permission in the text format, and this is the permission in the numeric format. So we'll see how this helps us in a minute. So before that, let us convert one more text format into the numerical format. So here we have this numerical format. Okay, so again we have the owner, these three for the owner. So here it has read and write. So for read and write, we have 4 + 2, which is 6, right? So these 3 is done. We don't have execute, so we have not considered it. Then we have 3 for the group. So here we have only read permission. So for the read, what the number we have? We have 4. So type 4. And then again, last 3 for the rest of the world or public, that is 4 also. So this is the numerical equivalent of the of this permission 644. Now, how we can use this numerical permission to administrate this permission? So for that, we will use a command called chmod, change mode, and then the permission. Let's say 644. Okay, and then the object for which we want to assign this permission. Okay, let's say dir1. For directory 1, so this command means we want to change the permission of the directory 1 to 644 or this format. So here, if you see the directory 1, it has this permission, right? This permission means 755. But now we want to change this to 644 or in this format. So so once I execute this command, And now I'll type ls minus l, and I'll see immediately this has changed to exactly to this this format. So now we have this tier 1 which will have this format. So now now the question is, when we have to use this file permission changes in real life scenario of the basis. So I'll give you a couple of examples. The first one is whenever you do any changes in your system. For example, you want to do a patch installation, you want to install a system. So at that time, if you are want to patch, upgrade your system, at that time you will have to use a tool called Software Update Manager, or SAM in short. Okay, and you need to download the SAM from the SAP. It comes in an archived way, so you need to extract it. So once you extract the SAM, you will have like 70,000 or 50,000 or 30,000 file, for example. Okay, now you have to change the permission. If you don't want to change, if you don't change the permission, the system will not be able to read many files, and you then it start throwing problems. So at that time you want to change the permission. Similarly, if you want to install a system, there is a software called software provisioning manager, which is SWPM in short, and that will again come with like 50,000 or something like that file. Again, after you extract those files, you need to change the permission. Otherwise, it will have similar kind of problems. So what you do, let's say we have a folder mkdir. So uh, we have the file, okay, and we want to change the permission to full permission 777. Okay, so what we do, chmod 777 sum. So as soon as we do that, we'll see that the permission is now full. So that is one thing you have to do over and over in your career, that you change the permission of the sum. Okay, now the question comes is uh, you have to change not only the folder but also all the file folders which they are in the sum. So as I told you, there might be 20 to 30,000 file in the folder. Okay, and you have to change permission for the all file folders inside the sum folder. So it is not possible for you to change uh, each and individual file folders individually, right? Because it is not a human task, and also it is extremely difficult, or I would say impossible, to keep track of the file folders which you change the permission and which is not changed yet. So in that case, what we do, we put a simple parameter which is R. R means recursive. So what it will do is, it will go into the sum folder and it will change each and every files and folders recursively. So it will go and list all the file folders, and then it will change the permission, and then it will go inside those folders and go inside. So like that, it will travel all the file folders in the sum folder and it will change the permission. So this is a command worth taking mention, a note. Probably this will be used many times. Okay. All right. So this is for the changing permission. Now I'll say a little bit about the user administration, and the group administration. So these are the things generally will be taken care of the waste level team or waste team or the platform team, but you need to have a solid idea on that, because you need to communicate with them properly so that they perform this thing correctly, or you get the correct output of them. Okay, so for user administration, for example, let's say we will start creating a user. Okay, so for that you will type command user add hyphen then the username. Let's say user1. Okay, so for that you need to be root. So let's go to the root first. As this is modifying the system now, it needs root. User add user1. So now user is added. Okay, so how you add user? User add command. Now I want to change the password for this user. So for that I'll use ESSW. Keep noting this these commands. Okay, user1. So now it is asking for the set the new password. So let's say I will give the PASS pass123. So it say that this is a bad password because it's a very easy password. You should not use it. But I will ignore that and I'll use the same password. But we should not ignore this, and we really should set a strong password which is not dictionary based. For example, I used pass123. So pass is a dictionary word, so that's why it is showing this here. Yeah. And so what kind of password we set is at least 10 to 12 character long. It has some special character, it has some number, it has some uppercase lowercase letter, and it does not belongs to any dictionary word. So for example, I can give the password as GKY7 this. This is probably a good password. Okay, this is probably a good password. So you also have to keep a habit of this so that your system is not hacked. Okay, so why this is necessary? Recently I worked in an organization where I'll have to do a HP upgrade. Okay, ECC HP upgrade. And for that, first we suggested them to build a sandbox by copying the production system, so that before touching the actual landscape, we do the upgrade in the sandbox system, so that we know what are the challenges, what are the issues might happen forehand before starting on the actual landscape. And we requested them to build a sandbox, the cloud provider team. So they said that we cannot have the sandbox in the SAP landscape. So uh, we will create the system in a separate virtual network. So we said, okay, build it. So they built the build the server, and now they are not able to um, reach the server, or we are not able to reach the server using VPN because it's in the different virtual network. So what they did is they add a public IP in the server so that we can directly go to the server without using any VPN or something. Okay. Now the problem they did is they created a very easy password. Okay. Uh, and we did not also give a very much thought about it. They sent the password and we logged it and we started using our recipe work. Okay, but in the few day times after the system was built, after 5 to 7 days, we see one day we logged in into the system and we see all the system in the file except the C drive, because if C drive is corrupted, then nothing works. We will even not able to log in. So what hackers did is they encrypted all files in the D drive, E drive. So we are not able to use the SAP system. We are not able to start the SAP system. Uh, so they encrypted all file and they said that, okay, if you give me that much of money, otherwise I'll not decrypt it. Your data is lost. But we don't have any impact because that is a sandbox system, and we created the sandbox system by copying the production system. So instead of paying ransom to them, we simply decommissioned the server or formatted the disk, and then we installed a fresh copy. And also we changed the password to a strong password. Okay, so that is the importance of setting a good password. And what they do is they create a script which will use a dictionary, and it will use different permutation and combination of the dictionary words and the 1 to 3 numericals and special characters to try break your password. So if you set this kind of password now, it will take them probably 100 years to get to this kind of combination. So that's why it is important that you set a good password. Okay, so now I have add the user. Now I will add a group also. Okay, so let's say I want to add a group. So for that you type group command gr1. So I add this group. Okay. All right. So now I want to see the details of this user. So for that I'll go to password file. There is a file called password in the etc directory. So if you go to the etc directory, then password. And here you see I added this user. Okay, and this is the home directory for the user. And now I want to see the groups for this user. Okay, user one. So you see the user one has a group called user. That is because whenever you create any groups, any user, there is a groups automatically created on the by the same name of the user. So if you, for example, if you see groups root, so you will see root has two groups assigned. One is the primary group is root, and secondary group is SAP INST. Okay, so let's say I want to see groups A4HADM. So again, the primary group is A4HADM, secondary group is SAP SIS and SAP INST. So there would be only one primary group, and preferably it is set to the group which is created along with creating this user. So if I create now a user called user123, along with it a group also be created with the same name. So user123 is the username, and group user123 will be also create, and that group will assign as a um, primary group, and you can use other groups as a secondary group. So I have created user one, and user one is the primary group. Another group is also added as secondary group, which is uh, users. Okay, now time by time you will have to add the user to different groups. Okay, so for that you will type the command user mod. Okay, user mod hyphen g. Let's say SAP. We want to uh, add the user to SAP SIS group. Okay, SAP SIS, and then user one. So small g is probably for primary group, and capital G for the secondary group. I don't remember properly. If we fire this command, it will be verified. So now I have added SAP SIS to the user one, or better way, I have added the user one to the SAP SIS group. Now let's see the groups for the user one. So see, it is the user one is added in the SAP SIS group also. So as I said, capital G is for the secondary group. If you use small g, the primary group will be changed, and that is not recommended. So why we need to add the group in different groups? Because there are certain activities which is required. For example, when you install any system, the root user must be added to the SAP INST group. So that you see that is happened. So SAP installer tool automatically does that. But if you add the user to the SAP INST group, that is even better. So that's how you change a user, and you insert the group. You insert the user part of a group. Okay. So we have this right now. We have this user one and group one. So reason I was showing you that. Let's go to the that folder once again. A4AJTM. So these are the files we created last time. We did not see these files because these files has a dot in front of it, and dot means hidden. In Windows, you simply set the hidden flag. I have not done that in some times. This is the hidden. So if you click that and apply, then it will be hidden, right? In Linux, what we'll do, or Unix, we simply put a dot in front of the file name. So it will be generally hidden, but it will not be not hidden when you run as a root. Okay. And also, if you are not root, other user, if you want to see the files, what we'll do, instead of ls-l, you just simply add a. A means all. So that time also you will see the entire list. And if you are root, then by default all the hidden files will be shown. Okay. So now we will see that how we can change ownership of the file. Okay. So up until this time, we have seen how we can change the file permission, how we can do the group administration, how we can do the user administration. Now we'll see how change of the ownership. To do that, we will use a command called chown, or change ownership. Okay. And then the format is change ownership, name of the owner, and then colon, let me write down, owner, then group, then the object name. I mean, the folder or file which you want to change the ownership for. So this is object name. Object. So this is the format. Okay. So let's say I have this group called dir1, and currently the owner is A4HADM, and the group owner is SAPSys. Okay. Now I want to change this to user one. Owner should be user one, and the group should be group one. Okay, or GR1, which is just we created. So this should be user one, and this should be group one, and the object name is dir. So now if we do ls-l, you'll see that it is changed to group one, user one, and group one. Okay. So whenever you extract SUM or SWPM in the WES level, or you use any other files from the external sources, you will need to use this command. And again, for this command also, if there are multiple files in the folder, if you want to change all folder to be changed, what you use capital R, so that all the folders in the directory, files in the directory ownership also change. So if we gist all these command or all these learning in short, in your real life, you will need to use these commands in your real life. Sorry. And you know the understanding behind it, right? You need to use this command. Whenever you get any file from the remote sources, what we'll need to do, you need to do 777. Let's say I have extracted SAM. Now SAM is extracted into a folder. I want to do this. I want to change all files under the SAM to 777, and I want to change all file permission to SAP. I mean SID ADM, which is F4 ADM, and this is to SAP SYS and so on. Okay. If you are doing this for SWPM, this name should be changed. So these commands should be executed whenever you get a file from, download a file from the SAP marketplace to do any maintenance stuff. Okay, so this is the idea behind your these are the few commands and few concepts which you will use, I would say, daily basis in your professional career. Okay, so let's go through few troubleshooting steps at the OS level. So as a basis consultant, time by time you will face different errors in the SAP system. Okay, and mostly those will be the user issues. Mostly those will be user reported issues or system unavailability or something like that. Okay, so for that we will be traveling to the instance folder. Okay, so when we receive the issue report now, I mean the moment you receive the report that there is a issue, so your first duty is to understand the issue correctly. So do not rush to the system until you understand the problem statement correctly. That will waste your time. Okay, so when you receive the issue report, and first thing you will see that whether my system is up or not. So in some cases there would be clear instruction. Okay, I cannot log in into the system. I cannot log in into the system. So first thing you need to understand that whether system is up or not, it is running fine or not. Okay, so what you will do is first you will check your instances. Okay, if anybody reports I am not able to log in, so first you will check your instances. How you will, even before that, what we will do now, you will simply open SAP login and you will try the system. If it is opening fine, that means it's the user's problem, network problem, anything else. But this is not, system is responding. So that is your first step. If you see you are also not able to log in, then you will see if you are able to ping the server or not. From the command prompt, you simply type ping, then IP address, something like that. Okay, whatever your IP address is. If the system is reachable, that means the network is fine. Now you have to understand whether your system condition is good or not. Okay, but if you receive any problem or any report which is some internal things of the SAP, for example, they are not able to open this thing, this transaction code is giving error, so then obviously there is no need of checking this thing. That will be unnecessary, right? But if it is something related to not able to access the system, you try it from yourself, it is not available, immediately you go to the OS level and you see your status. Let's say first you need to check your dialog instance. Okay. So here, if you see this plus work is down, this plus work is not working. So there could be two things happened in the OS level. Okay. One is any critical uh, operating system process which is terminated abruptly. Okay, there might be a resource crunch, there might be a memory address violation, there might be some internal operating system issue. For that, the dis plus work process terminated. So this would be completely gray. So in that case, you will need to restart this OS level. Okay, this instance. Stop this instance. If other processes are running, you will not be able to start once again until you completely stop the entire thing. So you stop this instance and start. But before we do that, there might be other issues. We will quickly check that. How? First thing we'll check the database is running or not. So for that, what we'll do, R3 trans -D. If it is 000, that means your database is fine. The dis plus work is down for other issues. Then we quickly restart the dialog instance. Stop the dialog instance. SAP control NR01 function stop. SAP control NR01 function start. Quickly do that. But if we see this is something else, then we need to see what is wrong with the database. You see the trans.log. Immediately the trans.log log will be generated here. After you execute the R3 trans, you will start you will start reading the trans.log to understand the issue. You can do one thing in between. When you are reading through trans.log, you can open another window and you can fire a restart command of the database. Okay, that might resolve the issue. Okay. So this is the one way to troubleshooting the start issue. Okay, but so database issues we will discuss later. What are the database issues and what how we can resolve it. Start, stop the database, stop everything. So for the time being, let's consider that okay, the problem is not the SAP system. SAP system is running fine, and user reported issue. Okay. So then you have to understand whether issue is any functional or configurational issue, or it is a system issue. Okay, and how we do that? There is no hard and soul rule for that. As you will progress through your professional career, you will face multiple scenarios of issues, and it will keep enriching your understanding of this topic. Okay, so that is the only way to do it. But to start with or to begin with, there are few things we can obviously say. One is, if you see any communication error. Okay, if you see any communication error, might be RFC, might be other communication. If you see any part of your application system is completely not available, few T codes are not available, few functionalities are completely not available, then probably it's some system issue. But if it is available and it is behaving little weirdly, then it might be a functional issue, might be a configuration issue. But if it is completely unavailable, if it is not reachable, something like that, then it is a system issue. So what we do is we will simply go to the dialog instance. Dialog instance of which the user is logged in. Okay. So in the dialog instance, there would be a folder called work. This is we call it work directory. In this work directory, you will find all the logs. Okay. So these are all the logs. So you have to understand the significance of these logs a little bit. So first of all, this is a standard output, you can say. So when the program runs in the OS level, program means the kernel executables, and they will simply output some prompts, right. For example, uh, we all have done some programming in the school or college, right? Let's say I am writing a program in the C, and that is goes like hash include stdio dot h, then main. Okay, so this is the example of the program. Uh, and let's say this is the kernel program, okay? And now we are printing this hello. So in the kernel program, there would be many this kind of print instruction, whether it is a C language, C++, or another language. So these basically goes to the standard output. Okay, so whatever in the program, whatever executed in form of print statement, that comes into the standard output. You got what is the significance of standard output? There is a program in the kernel which is let's say message server or enqueue server or dis plus work process. So whenever they are running, in between they will execute different print statements. So all those printed statements go to the standard output. Okay, and this error, standard error, is also in the program. There would be error statement defined. Okay, error try catch block. I'll not go into the programmatic aspect of in detail, but there are things like try catch block which will definitely trigger errors, or when error occurs, that segment is triggered. So those error messages will be accumulated in the error message. Okay, and also there is a dedicated log folder for each of the programs, okay, or each of the processes. For example, I have told you that when a system starts, it basically copies the kernel from the sys folder to other instance folder, right? And that is done by SAP CP .exe. So SAP CP means basically the copy program of the SAP CP. So that SAP CP basically synchronizes all the program to the other kernel folders or other instance folders from the sys folder. So that is the log for that. So sometimes when your program starts, sometimes it will show you the phase called synchronizing binaries. That means it is synchronizing or copying the binary files from the sys folder to other folders. So during that process, if there is any error, it is very common error that it is synchronizes binary to other folders and it does not have the right permission. So from sys folder, it is writing to D01 folder. But in the D01 folder, the file is already exist and it is already open. So that time it will not it will not be able to overwrite the file or replace the file. So that time you will see this SAPC log containing a line called this file is already in use, so cannot replace. Okay, and then SAP start log, stop log, that will be stored here. Okay, so but these are non-significant logs. The significant logs are here. So for each work process, you will see a developer log. Okay, so we have 33 work process, right? So for each there would be one. So this is for dev underscore 33. This is dev underscore 34 and all. Okay, so these are the logs for the work process. So, and if you have a problem, yeah, RFC, we have not learned about RFC yet. So RFC is basically communicating to the remote systems. So if you have any problem with RFC, you will find the log in the RFC files. And if you have a problem in the web dispatcher, you will have the log here. If you have problem in the ICM, you will see the log here. So what we generally do to identify the logs, obviously we will not generally go through all these logs, right? It's not possible. So the trick we use here is we use a command ls minus ltr. So what does it mean? ls minus l means you provide simple this output, right? And then t means let's sort this by time. Okay, I don't want any random output. Generally, it is when you execute L minus L, it's sorted by the alphabetical order with the file folder name. So ABCD starts with the files which is starts with ABCD comes first, and files with XYZ or S or any lower order character comes at the last. So this is ls minus means alphabetically sorted. So now we don't want any alphabetical sort, but we want sort by time. And in R means reverse order. That means the newest file will show up at the last. Okay. So the benefit of it, if we have huge list now, then if we don't sort in the reverse order, the newer files which is created or edited will be at the top. Then we'll have to again scroll to the top and see the file. So to avoid that, we use LTR or reverse order. Now if we execute, we'll see that the file which is recently edited, that is came at the bottom. So we can see this log was edited, right? So I'll simply read it like that, and I see the problem if there is any problem. So what we do generally is we ask the user to reproduce the issue, or we reproduce the issue, and the expectation is when we reproduce the issue and error, then the issue is logged in the log files. So issue is written in the log file. And once it is written in the log file, then it is changed, the timestamp changed, and it will come under the recently changed file. So that's how we see. So generally we read, if we know where the problem happening, we open the file directly. Otherwise, we'll probably read 5 to 10 files from here, and that will probably show you the problem is. Some cases you don't know where the problem coming for it. If it is coming from web dispatcher, if it's coming from ICM, coming from the work process, you don't know. So at that time you'll sort, then we'll read randomly 5, 6 files, 10 files. Yeah. But if you know, you will go to directly, you know that it is happening to the web dispatcher or ABAP dispatcher, you directly go to this file. But if you don't sort using LTR, only ls minus l, then you will have to search the entire list manually. But if you reproduce the issue, it is expected that the file got changed and it will be recently changed timestamp and it will show up here. Okay. So this is for the dialog instance. Similarly, you do same for the central instance also. So if you see that your ABAP dialog instance is getting down or yellow status, that is because your message server is not running. Okay. So you check the status of your where am I? PWD. Okay, let's go out of this and then CDS. Yes. So similarly, here also we'll have a work directory, and here we can see that log for the message server NQ server. So this is the log for the message server dev underscore ms. For NQ also there would be a log where it is. This is the NQ server log, and this is Also the gateway process log, standard error, start log of the message server. So you need to read those logs and try to find out error. So sometimes the line itself will call something like this, error in starting so and so. So probably you will look a line which is contains error or abort or stopped. So generally these we look for these keywords, and that will give you a nice idea about the error. So this is little bit overview of the of the troubleshooting. Obviously, we'll go in more details, but I'm stopping the session for today.
Hey there, want to level up your skills in managing supplies? Our SAP Basis HANA course is here for you. Take it at your own pace on our platform. In this course, you will dive deep into SAP Basis HANA, a powerful tool for handling supply management. It's like a toolbox for planning things, ensuring we have enough products and getting them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors are pros with tons of experience. They are here to guide you and tackle any questions you may have. And guess what? Our students love this course. Folks just like you have found it incredibly helpful. What's even better, it's affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA whiz? Sign up on our page now. For more info, head over to ZaranTech's website.